Check, check, 1, 2. Hello, hello. Seems like everything is good. Okay. So today I need to start figuring out Dijkstra's algorithm for the pathfinding and how I'm actually going to implement that. But I figure before that I might as well do all of the necessary checks to only spawn nodes where there should be nodes. Or would we be better off deleting nodes? No, we have to delete the nodes because the nodes get populated before anything's added. Hey, Fizzy Busy, how's it going? Right. So I need to like build my own version of the hands off my nodes. Get off my nodes. Alright. Before we would do like MP grid add instance or add cell, I need like my own version of that, which essentially removes nodes. Jesus Christ. Oh my god. Didn't think about that, did I? No, I was thinking about like not spawning nodes on tiles that are forbidden, but of course there's the instances. It can be done with, oh geez, I mean, collisions. You could use collisions. We might have to use collisions, or well, we don't have to use collisions. But it's probably the easiest option. This is just the worst, isn't it? It's like, you know, everything's always 10 times more work than you think, right? But I thought this was going to be a lot of work to begin with, and it's becoming apparent that it's going to be absolutely insane. Okay. Point collision. Point collision? Was that what we want to do? Point collision. I mean, the nodes are essentially points. We can check that point. That doesn't seem very... We don't want to have to check every single node every time we place something. We kind of we know where we're placing the thing, so with something with an object that's only one tile in size, like a tree, we know exactly which node we need to remove, kind of. We know the coordinates anyway. It would share the coordinates with the node. But something that's a multi-tile object, like a tent, it's still obviously really slow to check for collisions with every single node on the grid. But ideally I need this to be like a universal function. Hey Irish, they have root nodes? I guess not, because I don't know what a root node is. Root nodes? Oh, well, we know which cell the nodes belong to, if that's what you mean. They're grouped into cells. It gets really complicated when you think about the fact that objects could span 2 cells, and I've been wondering if I need to prevent that from happening, but that would be a bit weird. Ideally, I want objects to be able to span multiple cells and still work. What's a good example of that? The best example is something that can be accessed from all 4 sides. Well, I mean, tents are the same way until they're constructed and then they have an entrance, but the obelisk is a good example because it's 4 tiles big. It has a 4-tile footprint. It could occupy 4 cells at once. How would we... There's a lot of challenges to this. Yes, some of the objects are not square. Technically, in that scenario, the obelisk would be in the bottom right cell. Technically, because it's on the coordinates of like the top left corner of the cell. But it can be accessed from all 4 sides and 4 different cells. How are they going to understand that when attempting to path to it? As far as they're concerned, it's in 1 cell. They kind of need to, I don't know how you would do it, but they sort of need to pick the cell on the closest side or something like that, right? Yeah, there's a lot of stuff in here that I have no idea how to do. We need to like look at our target and find the closest adjacent node, which is exactly what we would kind of do with the cells previously, right? Yeah. So I can repurpose the existing code to find the closest adjacent node, probably. They don't. They don't anymore. We haven't gotten there yet. Previously I was using motion pathing, but it's too slow. So now we have to build our own pathfinding. So we can certainly do that, even if I'm not quite clear on the details yet. And that would dictate, because those nodes will only fall in one, just because the object spans multiple cells, the closest node will only ever be in one cell, of course. Flags. I was just not... No, that does make sense, actually, because it can change. Right. We should... Right. The map is divided into cells, which are filled with nodes. It's like grids within a grid. And that way, when we're pathing to something, we don't have to, like, check the entire grid or the entire map. We just find the nearest... We find the shortest path through the grid, and then pass in those cells to the next step, which then finds the shortest path through the nodes in those cells specifically, so it doesn't look at the entire grid. That's the theory. Yeah, the idea of flagging them as opposed to destroying them makes a hell of a lot more sense. So that's what my function needs to do. My function that adds instances to the grid, or my function that updates the nodes based on the position and size and shape of the instance. Well, of the sprite. I'm very distracted. Somebody's screaming outside. Okay. Well, the simplest thing to do is to flag the ocean tiles as forbidden and stuff, so maybe I should just start out with the simplest thing so I can kind of get a feel for it. The nodes themselves are all going to need an additional variable called forbidden, which will be true or false. Oh man. Well, at least children screaming is better than random psychopaths. Okay. Right, scripts. This is what I made yesterday. So the nodes are going to have forbidden. Can I just do it like that? I guess. These are apparently structs. You do this, it makes a struct. So I have been using structs in my save load system without knowing it. Okay, so everything's false by default, but we're defining the coordinates now. So maybe we want to also take this opportunity to check whether it should be forbidden or not based on the tile map, because the tile map is generated before we generate the Nav grid. Okay, let me grab that stuff from forbid cells. Oh my god, what is this? Oh yeah, we did some crazy shit to, like, oh my god, right, how am I gonna do that? I have to do that again. Because you can have small islands disconnected from the mainland that also need to be forbidden, even though they're solid ground. We did that with some insane method. This is getting out of hand. So I remember we like looked at the middle of the map first or something, and that was like island 0, the main landmass, the mainland, and that would always be it would always be unforbidden. And then whenever we found some other islands, we gave them a number as well, or something. Flood fill, right, this is what we were using flood fill for. Yeah, that would probably make sense. I'm still just figuring it out at this stage. I kind of forgot that we would have to do this. Hopefully I can kind of repurpose this. Could have probably commented my code, eh? Especially with this stuff. Okay, apparently we start from 1, not 0. And we just check. We just seem to start checking everything, actually. First we set everything to -1, whatever that means. And then we start looping through the entire map again. And if it would be helpful to update these with, I believe these are ocean tiles 3 and 4. 4 is ocean. 3 is deep water. Okay, that helps. So, we set everything that is ocean to 0 on the island map. Else, we begin a flood fill. So as soon as we hit solid ground, we begin a flood fill. I'm sure we did something where we like set the mainland first or something like that. I see something about mainland here. It's commented out. Flood search. Oh, I just hit the flood search in the middle of the map. Port Val, cardinal only, okay. Oh, shit. Be right back. Stuff arrived a day early, which is good. Okay, so we set everything that's ocean to 0. If it's not ocean that we're looking at, yeah, and it's still -1. That's when we flood fill. And island count doesn't seem right. Cardinal only. Oh, flood search? What the fuck is a flood search? Okay. We have a flood search and a flood fill. Where in God's name did I get flood search from? Wait, that's what the function is called, but it is actually this one. Okay. Is it? Flood fill. And this one's flood fill. Why is it opening flood search? This one's flood fill. Change value. We're changing it to island count. That makes a lot of sense. So we're counting up the islands on the island map. And then okay, so oh, flood search. I am actually using flood search this time. What the hell is a flood search? No idea. Mainland equals island map 0xy. So I think we number all of the islands and then we pick whichever one is the mainland by just looking at the center point of the map. It might be island 4 or something. So and then we set global mainland to be, well, it seems like we actually set coordinates there. I don't think these comments are correct. That's pretty cool. It's pretty cool. So, yeah, once we've identified all of the albums, the islands, then we find the mainland, and then we flag everything else as forbidden, whether it's ocean or an island that's disconnected from the mainland. So we need to run the same procedure, but flag our nodes as forbidden. Now these coordinates will be... I'm passing in map width and height into forbid cells, which is run in the loader, I believe. And I think those... well, we'll see. Pretty sure that's the width and height of the grid, as opposed to the width and height of the room in pixels. I could be wrong. See, map, fall off map, tile map. Whereas forbid cells, maybe it's actually in one of these other functions. Tile map. Oh yeah, this thing is insane. Oh, it's there. It's just commented out, of course. Room width divided by... yeah. So... can we make that work, or... I think we need to do it like one cell at a time on our new sort of nav grid. Checking the nodes in each cell as we go. Okay, so I might as well... I mean, do we just build it into the one function, or maybe it's cleaner and more readable to have a separate function? Probably. Close this for now. Where the hell is... oh boy. Well, I'm looping through these arrays when I'm drawing the nav grid, so I can repurpose that. I've written that yesterday. Because that's what we're going to want to do. We're going to want to loop through all of the cells and all of the nodes. Right? Basically. We can still use forbid cells, but I should probably make a new one called forbid nodes. But we can use the same method. Island map 0 is just an array, right? So we can still just create the island map in exactly the same way. So we can do all of this. And then the only thing that would change is instead of MP grid add cell, well, ideally, I would want to be able to look up my nodes based on the coordinates exactly like this. Unless I'm, well, yeah, no, unless I'm doing it cell by cell, which is I probably am, right? Interesting. Yeah, but then how would we correlate? Oh, that's where it gets confusing. If I if I bit shift the coordinates of the nodes, then I can get the positions exactly the same. Right. So we'd scan through all of the nodes in the cell and compare each one of them to the island map. Let me duplicate this script. SC navgrid create. Should I do like SC navgrid forbid or something? Is that how you spell that? Yeah, okay. SC navgrid forbid. Man. I'm the wrong guy for the job, but why on earth am I even doing this stuff, dude? My brain barely even works. Oh, man. I should be out there, like, lifting heavy rocks or something. Just something simple, you know? Jesus Christ. Okay. I'm still not clear on what flood search is doing in this case. Why is it necessary to... I don't know why it's necessary to do a flood search. I don't think it is necessary. All we're doing is setting, like... What are we doing? Okay, I don't know. I don't know, because we're setting mainland to X, Y of island map. Fuck. The two-dimensional arrays just boggle my mind still. I don't know why I struggle with it so much. I don't get what it's doing at all. Maybe go through it from the beginning. So we set everything to -1, and then we set all of the ocean to 0, and we set everything else to an island count. You know, each time we come across an island, we set it all to island count. Then we flood search at the center of the map, which sets... It would make more sense to, like, put that value in return, and then obviously I didn't know that at the time. That's how you'd normally do it, but what I'm doing is setting this global variable to be the island count of the mainland. It's like it's weird. It's weird. I understand it theoretically, I think, but not how it... Because I just don't really understand multi-dimensional arrays properly for some reason. And then we go through the entire map again, and anything that's not the mainland gets forbidden. So what, it's setting both of these? It's setting both of these to -1, is that right? Yeah, so both positions... And so the only reason it makes any sense is because we always scan through the cells in the same order? From 0 to whatever. I think that's right. The indexes are basically just correlated with a position. The coordinates that actually don't have anything to do with anything. It's only because we know that we're saying like 0, 0 is the top left corner or whatever. And I think 0, 0 is just set to a value. Okay. So when we look at this, we'll see both of these. I think both of these will contain the number of the mainland. And so when we do a comparison between this and okay, it still breaks down a bit for me at this point here. I'm confused. It would almost help me to use the debugger to look at what this actually is. What is actually contained in here after we've run the flood search. I can do that. Look at me using the debugger. It is incredibly useful. Just gotta reinstate that in the loader so it actually runs. No, I forgot to run in debug mode. So it will break sometime. There we go. Oh, it gave me an error on forbid cells. What? Still, oh my god, just because I'm trying to pass in the grid variable. Can't even do that. Just pass in 0 then, right? Pass in anything. We're not going to use it. Oh, also I'm looking at the wrong one because it's the old one. Bid cells. Passing in 0. Get rid of that. It's the only thing that uses it. Put the breakpoint at the start of the for loop so I can see what gets returned into this variable. Man, it's crazy how like cobbled together a lot of this stuff is. I just had no idea how anything worked, but somehow managed to fumble my way through it still. I would write things very differently now. Okay, there we go. We hit the breakpoint. Mainland contains the number 8. That's literally it. Okay. No, it's good. It's good. It clears things up for me a little bit because this and this is like the coordinates on the grid essentially, but then it returns what those coordinates contain. That's where I couldn't really wrap my head around. Right? This is like the X position, the Y position, and then inside of that combination of the X and Y position is the number, the island count, if you will, or possibly the ocean value that resides at that grid coordinate. And then we're just That's what. See, I get confused with arrays still because I'm like, there's two things here. Does that mean we're returning two values? No, no. It's a value contained at this position of the first array and at this position of the second array. Well, technically, it's the value is actually stored in this position. And this array is stored within this array. Yeah, I'm still pretty fresh to two-dimensional arrays. Okay, that's good. Okay, so we can reuse all of this. And then I clear the array at the end. But I never destroy it. Which is why we have a small memory leak there, which never really poses an issue because I don't tend to start a new game like over and over again, but these arrays never actually get destroyed. Okay, so back to our new script then. And I kind of need another script to contain my new, like, nav grid add cell function, or yeah, sure, we'll call it that, I guess. SC nav grid add cell. And we need to, actually I don't think we do need to bit shift anything. Wait, no, it gets complicated precisely because the nodes, why did I say add cell? It's supposed to be add node. We use nodes now. This is a nodes household. It's complicated because the nodes are stored within the cells. Yeah, there's an extra layer of depth. Fuck. Okay. So it's almost, oh my god. This can't really be like a universal function. It's a function that we need to run inside of each cell. And then how do we do the comparison? Well, the coordinates are still the same ultimately, so we can still compare to the island map that way. I don't know if I do want an extra function. Maybe. I think I just want to build it in here and then possibly put part of it into an extra function, but it wouldn't be much. The bulk of it is going to be in here. I Man, it was so much easier when we could use MP grids. Why did it have to be too slow? Okay, luckily I wrote this stuff yesterday that it loops through all of the cells and then loops through all of the nodes within each cell. So we have a thing that does that, which is pretty handy right now. Why is there a big gap here? What is that? Okay. Yeah, I can't just loop through the island map. Right. So actually I don't want this to be inside of there. I want to replace it completely, basically. Okay. So I'm looping through my cells, and then we don't actually need to do anything at this stage other than then loop through the nodes within the cell. Wow, this might be the most for loops, the most nested for loops I've ever done. Okay, and then we're pulling out the. Oh shit! What? No, I still need to. Okay, I do need that information. I need the coordinates of the cell to extrapolate. What am I doing here? To add the. Wait, what is this? It's like I'm offsetting. So I'm offsetting the node coordinates depending on what cell they're in. So the nodes are not actually giving us it's like context sensitive. The nodes don't actually contain their position in the overall map. They contain their position relative to the cell that they're in. Is that good or bad? Would we want to do it the other way? Because that can be done by like preloading that stuff up front, right? Separate generation? No, it's all generated at the same time. We have to determine which islands are disconnected from the mainland so that you can't path to them. I wonder if just preloading that stuff and then we don't have to do the extra step of like applying the offset. That seems good to me. So in my nav grid create. Okay. So we're just kind of baking that in, which seems like a good idea to me. There's less steps to do every time later on when looking them up, which is going to speed things up. Not by much, but it's better. And then the loader, disable this again. We don't run into any issues. That's all I need to do there. And then in the thing where we draw them, we can now remove that part. Just that bit. And they should still draw in the correct place. I certainly hope so. Because they are now, like, the offset is applied when setting their positions, their coordinates in the first place. Okay, hopefully that's correct. Man, performance issues are the worst. It's such a setback. It's like, in a way, I mean, obviously I was closer than I'd ever been to finishing the game. And then it's like, oh, actually it doesn't perform well. We have to fix that. Okay, there we go. They're all in the right place still. And I have 2 FPS. That's what happens when you try and draw them all. But yeah, they're in the right place. No issues there. Maybe I should zoom out and... Oh! Take a look at like the bottom corner. Make sure they're going all the way down to the bottom corner. Okay, that's good. So there's less work involved now. In the long run. So, where do we go from here? We're going to loop through all of the cells, through all of the nodes in every cell, and compare the... Are these real world coordinates? They are. So we need to bit shift the island map coordinates. There's the same number of tiles or whatever in the island map as there are nodes. So we can loop, we do need to loop through. Right, so... Oh shit, but oh my fucking god. Okay, how do I loop through the island map then? Because the island map isn't broken up into cells that contain nodes. So my method of looping is different. That's the problem now. Okay, so how do I loop through the island map then? Yeah, okay. we know how many nodes there are in each cell, so like multiplying this by the number of nodes or something tells us where we're at, I think. How do I do that? Okay. I can just use XXYY again because it's freed up now. A bit easier. So yeah, I mean, I still... What's going on there? Oh, I only need to loop through the island map based on the width and height of the map. No, wait, no, that doesn't work. Okay. Oh, wait. Do we even need these for loops if, yeah, if I can extrapolate from where we are in the cells and the nodes, then maybe I can just do like a... Maybe it just kind of goes in here. No. Oh, I think I forgot about the bit shifting. Can I just bit shift it? Yeah, we have the room coordinates here. If I just bit shift those, that will give me the grid coordinates actually. So bit shift it left take all of this and bit shift it left, I think. Oh, BS width. Like that. I think that gives me what I need, actually. It's a hell of a lot simpler than whatever I was doing. Right, if we just look at the coordinates of the node and bit shift it, it gives me exactly what I need. And then I put that in there. And then we're extracting the island number, or whatever, the value from the position on the island map and checking if it's the mainland or not. And now this is where we have to forbid it. We forbid it if it's not the mainland. And, oh, that's really easy now, isn't it? Because we're already looking in the right place, right? This one. Like that. Is that right? I think that's forbidden. Forbidden. Faux show. Forbid. Forbid? What did I call the variable again? Forbidden. That's a bit long. Should I just call it forbid? Forbidden. Whatever. Forbidden. It makes the most sense. Add a node. No. Forbid. Forbidden equals true. I think that does exactly what we need, you know? Just to run through it. So we loop through the cells on the grid, and for each cell on the grid we loop through all of the nodes in that cell. We take the coordinates of each node and bit shift it to get the position on the island map, and then we check the value at that island map does not equal mainland, does not match the mainland, the value of the mainland, in which case we set that node to forbidden. Pretty cool. And then I guess if I wanted to turn this into a function, that's where I'm a little confused. It may not be necessary, but no, it would be useful to have some kind of a, well, we're going to need to do something like that so we can add instances to the nav grid. Mesh? It's not a mesh. It's not 3D. We need to like change the color of the forbidden nodes or something now, so we can see if that's happening. Oh Jesus. Right, I'm using, I decided to use sprites because it's slightly faster than drawing circles by like half an FPS. Not much faster. So if the current node dot forbidden equals true, what I want to say, so I'll go with it. Else. It does look nicer when you put like spaces and things, but I went into like mad space saving mode. I need to make a new sprite. Okay, so we should draw a different sprite now based on whether the node is forbidden or not. And hopefully, like, all of the ocean and disconnected islands will be forbidden. Let's see if we even actually get in-game. I may have forgotten something that'll prevent us from getting through the loading screen. Yeah, this is a massive overhaul. And I've got to do the search algorithms as well, if you want to call them that. Oh, this is going to take a long time. Everything's forbidden. Everything is forbidden. Interesting. Why is everything forbidden? Fuck. Am I even running this script? That would make a lot of sense, wouldn't it? I don't think I pass in a grid anymore. I mean, I could. It is stored in a variable. It's global nav grid, but it's global, so I'm able to just look at it globally. Map ID, map width. What? Do I need any of this stuff? Why does flood fill open flood search? Map ID is used in there. Okay, still need that. Okay, so I think I can just get rid of grid if I want to, or I could pass in grid. Should we pass it in and replace everything that says global nav grid with grid? And then I actually need to run this thing. I'm guessing that it was. I'm still not totally clear on this, but I think scripts get run when you first launch the game. That's how macros get defined and stuff, or something. It's how your functions get created at the very start. So maybe this script actually gets run before the map has been generated, and that's why everything's forbidden? I don't know. Yeah, I have no idea. The cells are not forbidden by default. Did I possibly just get it backwards in here? If the cell is forbidden, oh, yeah, I got it backwards. We're supposed to draw the red sprite if it's forbidden, or the other one. I just had it backwards. So actually, none of them were forbidden. Not all of them. It makes sense because we never actually ran this script. So where I was previously running my old forbid cells script, global nav grid, now I want to run this one. NAC? No, nav grid. Nav. Not the NAC grid. Okay, well, it's spelled correctly there. What's wrong with it? Takes no more than 0 arguments. Excuse me? I think you'll find it takes 4 arguments just fine. I might need to restart GameMaker to fix that. It could have been because of the naming issue there. Okay. Right, we're actually going to forbid the cells this time. But this is only forbidding cells based on the tile map. Next, we have to forbid cells based on the instances. And then we also have to be able to update. Oh, shit. Island map. What's wrong with that? Line 31. We got pretty far through it. We got all the way to here. Presumably this stuff worked fine. And then it didn't like this check. So maybe I'm not bit shifting correctly or something. Let me find an example of bit shifting, because it's been a while. What's a good example of that? I don't know, do I do that in the spawn system for anything? Yeah, bit shifting left like that converts room coordinates into grid coordinates. No? No. No, it's the other way around. I'm supposed to be bit shifting to the right to go from room coordinates to grid coordinates, I see. Well, that would explain it. Oh, okay. We're in. Let's have a look at the edge of the map. Hey, how'd you like them apples? We did it. We have forbidden the nodes. That's what I'm talking about. Okay, so next up we have to forbid the nodes that are blocked by stuff and things. It's easy for anything that occupies only a single cell. I'm not so sure how I do it for... I mean, you could use collisions, but the problem is you have to check every single node, which is obviously slow. And we don't want to have to do that every time we, like, move an object or something. That would be really bad. I mean, it managed okay with the MP grid. But ideally, I don't think we want it to have to check the entire grid every time we place a tent down or move a tree or something. Yeah, also, like, how the fuck are the humans supposed... Oh, well, that's still done just based on proximity to the instance. That's fine. I don't think anything changes that. Well, I mean... I think it's okay, right? How is the spawn system even working right now? I have no idea. It is, though. It's working. Ah, right. It has nothing to do... I'm simply bit shifting room coordinates, and that just results in grid coordinates. So everything appears to be aligned to the grid, even though there is no grid. Why are the trees not spawning in the ocean, for example? Is there any... What is actually preventing that right now? Because we can only spawn them on grass or forest tiles. I see. You know what I still haven't done? It's been like a year and a half or something. I have not updated anything to support the diagonal tile, or like the transition tiles. Nothing can spawn on the transition tiles. It's just one of those things that has to be done at some point, but I've been putting it off for over a year. Yeah, I'm just thinking, like, how are we actually going to... Because before I could look at the MP grid and see if the tile that I'm, like, trying to spawn something in is forbidden or not. That's what I'm doing here. Now I, like, suppose I... Yeah, because otherwise we'll have trees spawning on top of trees. If we aren't able to check whether the node at the desired spawn location is forbidden or not, and I don't know how I do that other than looping through every single node and checking until we find the one that we're trying to spawn on. See, that is not... maybe I need to talk to Brewer about this. Like, how... Well, that's what I'm saying. Like, if it's a single cell object, it's fine, because the origin point just matches... Well, the origin point will always match a node, but the footprint of the object might be bigger than a single cell, so... And I don't want to have to write custom rules for every different object, although that's the fastest way that I can think of. Slowest way to implement, fastest way to execute. You know, I just if it's a 2x2 object, I look at the origin point and then I move one cell to the right and up one cell and left one cell. Although that still doesn't help me like quickly look up the nodes, does it? No, it actually, I still have to scan through every single node until I find a match. You know, I don't think it would be that big of a deal. So it's okay if that's what we have to do, because that's presumably exactly what MP grid cell, get cell is doing. Maybe. Actually, maybe it's not. I don't know. I don't know behind the scenes what that function is doing. Is it scanning through every cell on the grid until it finds a match? Probably. And it never really posed an issue. So can we scan through every node until we find a match? Probably. I'm just thinking if there was a faster way that I could come up with, I would like to do that. If there are any girls there, I want to do them. I would like to do that. Oh, jeez. Okay. How would you do that? So if our coordinates are within a certain range, we know which cell we're in. We can find that out quite quickly. And based on this still only really works for one cell objects. Jesus Christ. So I do need an SC nav grid get node function. I know I don't really need to put SC at the beginning of them all, but I'm just used to that. I need to be able to. Yeah, but I mean, the thing with nodes is that they're a single point. It's not a cell on a grid. Maybe we should still be using, well, the MP grid is, maybe we should still have some kind of grid. I don't know. It would, no, that doesn't make sense. No, I'm going off the rails a bit. I don't know. I gotta take a leak though. I'll be right back. Yeah, objects can also span multiple cells, so just scanning one cell is not really good either. We basically need to scan the entire grid. I can't think of any other way of doing it. You could use point distance instead of collisions, right? Well, no, not point distance. Distance to object. Oh, no, you can't use distance to object. Yeah, it's like, I think we kind of have to use collisions. Well, you could use... I think basically we just have to use collisions and we have to check the entire grid. Holy shit. That means you have to run a collision check on every single node on the grid? That can't be good. That cannot be fast. Collisions are supposed to be really slow, and I avoid using them. Okay, you could do it within like a bounding box. That would just be a comparison between, like, you say, is the x coordinate greater than the left hand side of the object and less than the right hand side of the object, and is the y coordinate greater than the top of the object and less than the bottom of the object? If so, then we know that it falls within the object. It's going to be the fastest way of doing it because we don't have to use collisions. Yeah, it might be the way to go there. So, well, one thing I need to do is draw. What is this? Objects, game. I need to draw this in front of everything, so I got to set the depth of this object to be minus 16,000, I think. That also means that all of the health bars and stuff are going to appear in front of everything now, which is probably a good thing, actually. No, the health bars aren't drawn by this, are they? Not much stuff. Yeah, what is drawn by this? The grid title? What is that? Who knows? Title? Tile. I can't even read. Holy shit. Okay, that's fine. That's fine. That's fine. That's fine. I might change it back later so this stuff doesn't draw in front of everything. This is like the thing that the indicator or whatever it is when you're trying to place down a construct, when you're building something. You know, it's like it turns red if you can't place it there and that sort of thing. Might look better when it's in front of everything, I don't know. We'll find out. Okay, so now at least my grid and stuff is going to draw in front of everything so we can see if this is working properly. And then I need a new function. Oh, I already made it. Navgrid add node. That's basically what I want to do, isn't it? And then we need to loop through the entire grid again, so let's get that. And I don't want to draw any of this stuff. Okay. And we don't need these coordinates, I don't think. I'll sort that in a second. Do I even need this? I don't think I need any of this. So just looping through the entire grid, looping through all the nodes. And we're going to do like... Okay, this one adds a single node, presumably, based on the name. And then we would want a SC navgrid add instance to do the other thing. So all this one needs to do is take whatever coordinates we give it and then do a comparison. Right. So we just throw some coordinates in there. You know what would be better actually is if we could treat it as if it was a cell. Right now we have to like provide exact coordinates down to the pixel. We can actually, I think we can bit shift it and then unbit shift it, basically. So XX equals XX. Which direction do I go again? I bit shift right. Okay, and then bit shift left. So we take the room coordinates, we turn them into grid coordinates, and then we turn them back into room coordinates and then apply the offset. Plus cell width divided by 2. So whatever we throw at it, it will kind of snap it to the nearest node. Something like that. Pretty useful, right? I think I'm doing it right. What was the example I looked at before? Like room coordinates. You shift the room coordinates right to get the grid coordinates, and then you shift the grid coordinates left to get back to room coordinates, and then you apply the offset to get to the center of the cell. Okay. So we don't have to be as precise. We'll always like snap to the nearest node, basically. Pretty sure it works. What's a good way of testing this one? We could use it for the trees or something, because they're all a single tile. Although I probably would want to still convert those to use add instance later anyway, just because they are instances. Maybe, I don't know, it would be, this is probably still faster. Probably do want to use this wherever I can just because it's faster. Spawn, nope, I was talking about plants. And then previously we used to do MP grid add in, blah, blah, blah. Now we're going to do, sorry, what was the, yeah, you just feed a fucking instance into it because it was add instance. Now we're doing spawned tree dot x spawned tree dot y. We just throw those coordinates into there, and hopefully the node where the tree is spawned should be flagged as forbidden. Now the next thing that we have to do is we have to be able to look at the nodes before spawning the tree and check that it's not already forbidden, because then we'd be spawning it on top of something else. Basically, we'd be spawning it in a forbidden location. A forbidden node. Do that for the bushes as well, why not? Okay, right. So there's nothing in the spawn system that prevents stuff from spawning on top of other stuff right now. Oh, what the fuck? Assignment operator expected. What does that mean? Oh, I'm using equals instead of equals. Whoops. So all of the nodes on top of the trees and bushes should be flagged as forbidden. We hope. Oh god. This is not a good sign. This is obviously not viable. Oh my god. I'm assuming it will load eventually. But it just takes so long to flag the nodes. So, yeah, MP grid add instance is pretty fast. It is, yeah, actually I left some debug code in there and it is spawning the trees extremely slowly. Oh, we got through it. That is fucked. We definitely don't. The loading screens were already slow. We don't want them to be even slower. That would be terrible. But it did work. It did at least work. They look a little bit off center to me, but. Oh my god. Right, so it's too slow to use that method. I can't think of a faster method though. I mean, we don't have to do the bit shifting if we just thanks, Scarborough. I'm gonna have to grab another drink. I'll be right back. Okay, dude, have fun. I would like to disable those debug messages wherever they are. Where are they? I think I have a... There it is. Get rid of that. Oh, this is deeply concerning. Yeah, adding instances to the MP grid was really fast before, but this is incredibly slow. So we need like a faster way of, I mean, yeah. We can't scan through the entire grid until we find the node. We need to like skip directly to the node somehow. Oh yeah, I got to stretch. if I can figure out which cell I'm in, then presumably we can use the coordinates to go directly to the node that we want. Right, right. Yeah. Really more complicated because it's compartmentalized. Because I can, previously, you know, I could just bit shift the coordinates to get the cell on the grid. There's probably some way I can bit shift the coordinates to find out what cell I'm in, and then bit shift them again, but differently, to find out which node of that cell it is. That's probably it. I think I guess the first step is that I need to work out how much I need to bit shift it by. Oh my god. I'm not even sure this is possible. I'm just kind of assuming it is because it seems like it would be possible, right? Because we're just dealing with bigger cells. We just need to bit shift it further. What are the dimensions of my grid again? (32 by 32). Okay. (1024). 512. If I took 1024 and 512, how much would I need to bit shift that by? Am I working in decimal or hexadecimal? What the hell is hexadecimal? $16 rather than 10 as its base. Yes, I believe I'm using hexadecimal. Am I? I guess. I mean, I'm working in like increments of 16, 32, and so on. So does that mean I'm working in hexadecimal? Beats me, man. According to this, if I bit shift 1024 13 bits to the right, I get 0. And I guess if I bit shift 512 13 bits to the right, I get 0. So I suppose the thing to do would be to like just test this. Yeah, I get 0. Okay. So if I should check this with some other values, I suppose. Well, I guess it's going to be anything below 1024. What happens if I go above 1024? Oh, I still get 0. That's concerning. Yeah, that is not good. Because that is where our next cell would begin. So I'm not doing this right. Maybe I'm actually using decimal. I don't know. Seems to require a pretty big number to get down to 0. Can I actually get down to 0? Whoa, what? Okay, the numbers have gone up again. What's happening? Okay, I don't really understand this. Okay, I don't know. Well, I gotta take a lunch break anyway, and maybe figure this out when I get back. Thanks for watching. I'll be back in a bit.
called a doubly linked list. And so essentially Dijkstra's algorithm takes it. Sorry, I'm hearing myself.
Oh, I just re-enabled audio on stream.
Oh, that would do it. Okay, yeah. I didn't realize I had you off mute there. Okay, that's on me. Anyways, so Dijkstra algorithm takes advantage of this doubly linked list. And essentially what you want to do is, instead of even having the node, okay, let me take one step back. Don't even add any kind of neighbors to the individual node that are forbidden.
Yeah.
So essentially, the Dijkstra algorithm will just go through and ignore any nodes that are not attached through this linked list architecture that I just described to you.
Excellent.
So the best way to implement this is basically to have a array in each one of your nodes that is designated as a neighbor. And what you have to do is, this is very intensive front loading, which is one of the reasons why, like, you load a game, you get that loading screen. It is because something like this is probably implemented, where you go through and you link every single one of those nodes to their neighbors in whichever form that you want. And if it is forbidden, you just simply don't link it. So when Dijkstra's algorithm goes through and starts looking at all the neighbors, it doesn't see it because it's not linked.
Okay.
So instead of actually checking like in the array next to each other, all you have to do is just scan the neighbors that are in the neighbors array inside of that node.
Right.
And Dijkstra's algorithm also has the way that it traverses everything. How do I say? Once I'm trying not to dive deep into like software engineering terms here that you might not be familiar with. So I'm trying to figure out the best way to describe this. See, basically, Dijkstra's algorithm will then not actually go through and process every single one of the nodes, because the way it works is that once it finds the node, it will then look at all of the combined weights, because you give a weight to each one of those connections, and if it has a weight, let me say this, if the current weight that it has, like when it's connecting to that node, is equal or less to all the other weights that it has detected for all the other nodes, when when it's trying to find the shortest path to that node, it will instantaneously stop the algorithm because it knows it's already there. And that linked list architecture that I just described prevents you having to continue to look through and scan all the other nodes for the forbidden ones. So essentially, just, well, by doing the linked list, it will almost always guarantee, assuming that all of the nodes have the same weight between each other. The first time it sees it, that will always be the shortest path to it. If that makes sense. So that's the advantage of everything that I just described. So
yeah, I can see the advantage of not having to check the forbidden nodes at all, because they're just not classified as neighbors. That's obviously faster. And I see the advantage of it. I didn't fully understand, but it stops scanning once it's found the shortest path versus I don't know. There's some way in which it knows, like, oh, we don't need to continue looking. We've definitely found the shortest path.
Yes. Essentially, there's two scenarios that I can think of readily. There may be more, but two scenarios that I guess would be significant for you. And it depends on how you want to adjust the weight. So if you recall, the other day, I said when I told you about the different like terrain, if you want to move faster through the terrain
Yep.
or you want it to go around or whatever. Um, so putting that to the side for a moment and just thinking of you make everything the same weight.
Which
If
is the
you make
plan.
everything the same weight, okay, perfect. Then I won't even. Well, I could address the other one just for understanding. But for what you're going to do is if the weight is 1 for everything, then that guarantees that it's going to be the lowest possible weight when it sees it for the first time. Because it will have scanned everything. Because if you think of it this way, if it's scanning all of its neighbors and then it goes to the next node and scans all of its neighbors, and then goes to the next node and scans all of its neighbors, it will link directly to the path that you want in the shortest possible time. Because the first time it touches it, it guarantees that that weight is going to be the lowest. I'm trying to figure out a better way to say this, and I'm having difficulty.
Yeah, my confusion
it's
is
like
that the weight would be exactly the same to all of its neighbors.
that is correct. So, there is a sense of priority within the algorithm as well. And the priority is whatever is at the top of the array. Or whatever, however you access the array first. Typically, you start at the 0 index. So let's just assume, quote unquote, 0 at the top of the array for the neighbors array specifically. So whatever is, again, the first part in the array is what will be scanned first, and so that has a priority. So there is a possibility that it may have a node where it may instead of going from the right, it may go from the top or something like that, depending on the source node to the end node. There are edge cases like this, and there are ways to overcome them, but let's see if that is even a problem first before we try to address it, because it does take some minor changes to the algorithm to fix something like that.
Mm.
So I would say once we reach that point, then I can sit down with you and look at your code, and we can kind of work that out.
Mm-hmm.
But the way the Dijkstra's algorithm works is there's 2 different types of search algorithms that you can do with it. There's one is called breadth first search, and the other one is depth first search. And Dijkstra's uses what they call breadth first, where it will scan the entire array first. Okay, take one step back. It'll take a node and it will look at all of the nodes that are in that neighbor array and create what is called a priority queue for all of those nodes. So whichever node it touches first, the top of the array, it goes to the top of the priority queue. And then it will go to that pop off the first of the priority queue, which is the first node at the top of the array, and then it will look at all of its neighbors and add all of those neighbors to the bottom of the priority queue. And at the same time, it does actually track every single one of these neighbor nodes individually by using recursion. Do you know what recursion is?
Yeah.
Okay. There is a way to do it without recursion, but the simplest way would probably be recursion. Because, how do I say this? The problem with recursion is it's more memory intensive than not, than processing. So it might be better for you to use recursion. However, that can get real messy. I'm sorry, I'm beginning to think through some of this a little bit. However, let me look at my algorithm here and see, as I don't think it's actually using recursion. Also, something to consider too is you might look at using AI to kind of help to get some of this the code together for you, because it will make your life a little bit easier. But understanding the code is absolutely paramount.
Yep.
But essentially, yeah, you can do it without using a recursion, but that's basically how you learn to do it, at least how I learned to do it in college. But you can basically just set up a for loop, or it's a while loop. While that priority queue is not empty, it will loop through all the nodes. So you can also just do that, which will probably ultimately actually be easier for you to understand, because it is a little simpler.
Okay.
But anyways, sorry, I'm jumping around here. I apologize. But essentially, it's as the algorithm traverses each individual neighbor, it adds it to the priority queue. But by breadth first, it's basically just checking all those surrounding cells. Then it'll pop off and check all those surrounding cells and add it to the priority queue, and then continue to check all the neighbors surrounding it. Where a breadth first search will actually take the first of the top of the priority queue, and then add the top of the the neighbor's array list on top. So you would keep pushing it on top. So you would actually traverse the entire freaking tree every single time you use depth first search. So that's one thing I just wanted to point out, is make sure that when you create the algorithm, that you scan all the neighbors first before you go to the next node. If that makes
Okay.
sense.
Struggling to visualize it a bit. You complete scanning
Yeah.
all of the current neighbors as opposed to scanning the neighbors of the first neighbor and second neighbor and so on. Is that correct?
Well, scanning the yes, essentially you want to scan the primary node. We can call this primary node, and then a neighbor node.
Yeah.
So their primary node, you'll scan all those neighbors, and then once you have scanned and added all of the neighbors for the primary node to the list, you then go to the first neighbor that you added, which is now the primary node,
Yep.
and then you scan all of those and add them to the bottom of the queue.
Right.
So then when you're done with that, you then go to the second neighbor, assuming there is one, of the first primary node, and then that one becomes a third primary node. So yeah, basically what you just described is correct. You scan everything first, and then you scan it in the order that you see it
Yeah.
within the priority queue. So yeah.
The other way seems very convoluted.
So exactly. Well, they're both correct, and they both have their advantages. However, for what you are trying to do, you just need to make sure you do the breadth first. But I'm actually going to give you my entire Dijkstra's algorithm. There are going to be some things in there that I have added. However, I can talk through this a bit with you. Let's see here. May actually want to see. And it's putting it as message.text. That's not what I do. Copy. Or is it too large? Nope, it's wanting to put it in message.text. Move this up so it will just be that. Okay. Okay. So, well, damn it. Sorry, let me open up. What's the best way to do this? Actually, a better idea. One moment here. I can just give you this. This, okay, cool. This is Dijkstra's algorithm that is without any addition. This is a pure Dijkstra's algorithm for nodes. Let me give you the add neighbor part. Hold on, that may not be the right one. Okay. This actually, crap. Let me delete this one. This isn't the right one. This one is one specifically because I can't. I'm having multiple lines cross each other. You are not. This has more functionality in it than you need. Let's see. Okay. Okay. Yeah, this one's using that. Sorry, I have multiple versions here that I'm trying to pick through to make sure I give you the best one for your scenario.
Yeah.
Let's not use that one. This is one. This is the one I want to give you. All right, the node. It looks like this one is it. Okay. Yeah, though this one here, instead of putting everything in an array, it creates DS maps for the neighbors and
Okay.
the weights. You could change it to not use DS maps. The problem with the DS maps is that you have to manage the destruction of them. But then again, it's not difficult, but it actually has a helper script that will help it. So,
Is there any benefit to using DS maps in this case versus arrays?
Well, not sure, honestly. Not that I can think of.
Okay. I'll probably use arrays then, unless it helps to use maps. I'll stick to arrays.
Yeah, I cannot regularly think of at this moment. There may be a reason, but I can't think of one. Because I do use arrays in mine. Because I'm just probably
ODS
should just give
lists?
into. That's yeah. I'm sorry if I said something else. You will need to use a DS map for the connections, though. Hold on for the map of connections, which I'll explain that in a minute.
Okay.
I'm going to go through and kind of describe what all of these are for you. Okay. So the last one is just kind of an example of how you add things together. But the first one I sent you is the individual node. As you can see, it has the neighbors, DS list create, and the weights. Everything else on there, I'm pretty sure you can kind of figure out. The visited equals false, meaning has this node been visited? Because you are going to have neighbors of other nodes that have already been touched, which is fine, and that's what that value is there for. And the distance is currently infinity because how this algorithm works is that it will actually store whatever the current distance is on the node itself. And since GML does not have any kind of threading, at least I don't, to my knowledge, that there may be stuff you can do for threading, but I'm assuming you don't have threading, you can do this. If you do ever introduce some kind of threading, you will have to revamp this, and it is not an easy task to do.
Yeah, I'm not planning on that.
Just a heads up.
Okay.
But I'm not even sure GML can do threads. I honestly haven't looked into it.
I don't think so.
And then the previous node ID in shortest path. So, but yeah, that's self-explanatory there. But the next one is the actual algorithm itself. So it will, like it says, it shows, it will create the priority queue. It will then first go and reset all the nodes because, like I said, everything is stored for the shortest path on those nodes. So it just set everything to false, the distance back to infinity, and so on and so forth. Then it will go through and will first add the first node to the priority queue, and then it will actually enter into the while loop that is actually going through and finding the shortest path. So, like right after it says the main loop while the DS priority is not empty, pop the current item at the top of the priority queue, which at this point will be the first one, and then there's nothing in the priority queue. And it will make sure that nothing is visited, and then it will check all the individual neighbors, make sure that that neighbor does not equal itself and has not been visited, and then if it has not visited anything else, add it to the priority queue, add its weight, and make the appropriate adjustments on the individual node. And then look back through, and you will continue to do this until it locates the ID of the node you're looking for. And then since it is the first time it finds it, and everything is a weight as one, it will stop right then and exit the loop. This is the way it should work.
Mm.
However, I am looking at this and I am seeing a problem because it is saying while the priority queue is, hold on, what does it say? Hold on, is there a break in here? There is not. So there is a problem with this. The way that this one is written, it will still traverse everything.
Mm.
So let me see I'm thinking of a way I can modify this real quick. Because for mine, it's not a big deal because I don't have a ridiculous number of nodes. And I only do it like if a mouse is hovering over something for mine. So it's not a big deal for me, but for you, it is going to be a problem.
Yeah.
So give me one moment here to think about this. Unless the neighbor's distance. I have to reconnect path to target. Because the next one is actually creating the array that gives you the list of nodes to the shortest path to the end node. So var current ID equals target node. That just breaks out. Hmm. Yeah, I'm gonna need to look at. I'm sorry. Give me a few more minutes here. I'm just trying to reconnect everything in my mind because again, my brain fog. I was describing in the message. Uh, push reverse path. Okay, that's correct. And it destroys the priority queue. Okay. I
Thanks for the
think
raid, 8 bits a byte.
it's less than neighbor distance.
We had a good stream.
Hey, bud. Sorry, my cat. Demanding attention suddenly. So at the bottom of the for loop, let me see if I can edit this. Bottom of the, sorry, the while loop
Yep.
of the main loop. So directly after the check neighbors, let's see, for loop. My neighbor.
Is it the continue by any chance? I don't know what continue does. Does it like not continue if some certain condition is met?
It's similar to break, where break will completely end the loop. The continue will end that current iteration of the loop.
Oh, interesting. Okay.
So, yeah, so that way, if like it's already been visited, it'll continue, so it won't add the weight and the new distance and everything else to it.
Hmm.
So, but yeah, you need to add a break for if you find that node.
Hmm.
I'm just trying to make sure if you do break, it doesn't do something that and cause it to crash, which is what I'm trying to piece through right now.
Okay.
I don't think it will, but I just wary. Distance, no, it should be fine because it would just end anyway. Priority, DS priority queue add.
Yeah, I'm just working with Brewer right now. Not the original task that I had in mind, but I'm not gonna stop him. I'm gonna let him run with this because I'll need it eventually. Anyway.
I think you basically just need to do if current ID equals, where is that? This. This should work, but again, I'm still wary. Save. Also added a note to it as well. Okay, and the one I added down there is outside of that for loop through all the neighbors. Wait. Shit. Although I kind of jacked up the brackets there. That for loop. Okay, that is right. For that, but is that the right location? Sorry, you're seeing in real time how I process some of this information, and sometimes my memory issues cause me to forget something. So if it is a current ID, it will break. So, and everything is already added. Yeah, that's fine. Yeah, that will work. There shouldn't be any problems with that. If we do run into a problem, I'll help you get through it, of course. But I think, well, when you look through the Dijkstra's algorithm there, does it make sense of kind of what's going on as a way I was kind of describing it to you?
Not so much right now. I'm gonna need to, sit down with it for a while and read through and
Gotcha.
just wrap my head around
yeah.
it. Yeah.
Yeah, this is a fairly advanced thing, so don't. I say I'm going to say don't cause yourself increased stress or anxiety about it, that it's hard to understand, because this is not something that a lot of people can understand very quickly. This took me a very long time to really wrap my mind as well.
Yeah, it'll just
Even
take time.
especially with the college assignment, I think this one took me 16 hours to do. Ooh, had 2 weeks to do it. It's still. But I guess the main things they're really quick to add is the add neighbor. So you would pass in your node map of everything, and it will go through and individually add the neighbors to both of the nodes. So take note of that, as well as their weights. And the last one is kind of how you would create the map to begin with, of all the nodes, and then how you would add the neighbors to them. So they are two separate functions. You cannot put them in the same function.
Okay.
It will cause you problems. So you just have to create a map, add them all together, and put them in there, and how do I say, add all the neighbors to it. So there is going to be a confusion point, I think, for you. And because I'm trying to see how I can marry this together for you, because what you're basically going to have to do is have a parallel type file structure with this. Technically, you don't. Sorry, give me a moment here to think through it.
Mm-hmm.
Because the original advice I gave you was for something that was similar to mine, the way I'm doing it. Okay, there's an advantage. Okay, sorry. Essentially, what you can do here is, like I told you, to create that 2x2 or that 2D array. In theory, you don't necessarily even need to have that 2D array with this now. However, I would still advise you to have a 2D array, because it will make accessing everything significantly easier for you than having to traverse through the map to find a specific node.
Yeah.
In the map. However, a map should theoretically go right to it. The way you access a map and the way it's done in code, it will theoretically go right to the node if you're trying to access it. So do keep that in mind. However, for the sake of understanding where everything is in the world easier, it may be a good idea to go ahead and have that 2D array, and as well as create a map, so you technically have 2 points of access to the same information.
I see.
The disadvantage is that it does take a little bit more memory, but not a significant amount, especially with the size of the way you're doing it. But the map by itself is a lot cleaner. However, it's not that big of a deal.
Sorry, bro. I gotta run. My food is ready.
Oh yeah. I'll stand by. Don't worry about it.
Oh, okay, cool. Give me a sec.
Yeah, take time. Now chat is mine. Ha ha ha. How you guys doing? If you don't know me, I'm Brewer. I'm sure most of you in there know me, assuming you're listening. Oh, Dijkstra's is one of my favorite algorithms.
Okay, here we go. This should help bring my brain back online.
I understand. I don't eat until like dinner time. I do intermittent fasting most days, so
Okay, cool.
yeah, mostly just because I'm not active. I don't want to get fat again. I used to weigh like 225 pounds. Now I'm at 185, so I'm gonna stay here.
Good on you.
Yeah, definitely was hard at first, but got easier. I'm still the kind of guy that will eat if I have food in my house, so. But getting better with the discipline. That's one thing I've never been very disciplined on was food. So never been fat, like really big, but still, once I hit my 30s, it kind of got easier to get fat. So, anywho, um, let's see. Where was I at?
You just
I think
were explaining why maybe having an array as well as a map could be
Oh,
useful.
yeah. If you continue to have performance issues, um, you can basically front load or only load certain things into the algorithm at that time in order to search. I've been trying. That's right. I'm trying to figure out the best way to. Well, we can cross that bridge when we get to it. But essentially, if you have the 2D array, that way you can access all the nodes easier if you're not doing the search type of thing. So if you're just trying to put information, or I mean, again, I don't know how the game is really coded very deeply on your end, but if it's easier for you to think in, the 2D array type thing, and to access specific information about the individual nodes and the access information or the number of buildings inside like the larger node versus each individual node. Having the 2D array would be ideal.
It's
And
probably not, to be honest with you. I still really struggle with 2D arrays. They confuse me a lot.
well, this is probably going to confuse you more.
Okay.
Yeah, it does. I'm not gonna lie, the 2D arrays do sometimes just kind of make me. Well, I may have just gotten used to it because I'm actually thinking to myself, it's like, yeah, actually, I kind of get it in a way. I'm not a fan of how the 2D arrays have to be created in GML, but it is what it is.
Hmm.
But
yesterday helped me
solely,
definitely get a bit of a grasp of it.
Good. If you continue your game making journey after this, you will probably find that you will need 2D arrays in many locations.
Indeed.
But like I said, you could get away with using just the maps and the nodes,
Mm-hmm.
and you just have basically one giant map of all the nodes. And like I said before, the compiler will as well. The compile as well as the execution of the GML code itself, the way it throws it into memory, the stack and heap and all this kind of stuff I won't get into. But it just basically assigns the key to an exact location in memory at the memory address. So it will always go directly to exactly where you want it to be.
Right.
There is a kind of bit of a loop in there too. But anyways, I won't get too behind the hood there. But it is exceedingly faster.
Yeah.
And it's due to hashing. Sorry, I'm remembering things from college. As I go through and talk about this, my eidetic memory's throwing so much information to the front, I'm having to sift through it. Anyways, but it would be actually increase everything to access the information faster. The problem is trying to track all the individual nodes as from the programmer side of it. I have some difficulty with that. You may not. But if you could get away with not using the 2D array, you would probably be okay. But the problem I have is you tracking like where the tents and other stuff is. So
yeah, I haven't even really thought about that. Some of the questions I've had is like, can a instance overlap multiple cells, or is that something that needs to be completely avoided?
yeah, that's a problem. And that is where you'd probably that is probably the reason why you would want to have a 2D array. A 2D array of the greater nodes, and not a 2D array of all the lesser nodes would probably be an easier way to think about it. So if you have I'm just going for the sake of argument, the 10 by 10 grid, but you only want to allow one tent in each one of those grids, but inside of the grid you have a 10 by 10 nodes type of thing. The array would allow you to individually track the tents, and it would keep it separate from needing to, constantly traverse all of those nodes with the tent in it. And you just have to write a function to basically add something that those are now forbidden and then remove the links. The only problem you're going to have is if you destroy a tent, how do you relink them?
Yeah, this has kind of been my problem today, figuring out how do I, first quickly find the node in question, and then, well, I mean, that was my main problem. I hadn't even, I wasn't even thinking about the linking stage. I was just trying to find them so that they could be forbidden or unforbidden, and then that would have all come next.
So there is something that I'm doing that I'm going to add to the algorithm here. And I'll show you where I'm doing it. As well as make a quick note. So there is a way. How do you spell forbidden? Oh, luckily, there it is. Okay. That. So the first thing I'm changing here is at the top one on the node, I added the forbidden equals false. So if a node is linked, it should not be traversed due to a build object set to true. So what this will do is you basically, when you add a tint, you add, set that to true or whatever object, whatever, set it to true. So it will not be added to the path. However, it will still be traversed using the algorithm. So what we need to do now is go into Dijkstra's algorithm, and under the check neighbors, let's say if the neighbor is undefined or neighbor is visited, or neighbor dot forbidden. Spelling forbidden, right? Because I suck at spelling. It will just continue. Come on. Where am I at? Oh, there I am. Maybe, perhaps. You want to work? Oh, okay. Sorry, Discord being weird on my end here. There we go. So I added, here, I'll make a note on here as well. There we go. So if you look under the actual algorithm, under the main loop, third line down in the for loop of check neighbors, that for loop there. It's like if neighbor is linked but is forbidden, do not add neighbor to PQ. And I spelled neighbor wrong, whatever. No, I didn't. Anyway, but the neighbor dot forbidden, if that Boolean, if true, just continue. Sorry, hit the mic.
Yep.
Does that make sense what I did there?
Yep.
Okay. So that will take care of your pathing problem through structures. However, you will have to create a function that when placed and it's, at this location, all the neighbors that are, or all the nodes that are touching it need to be set to true for forbidden.
Yeah. So is this, rather than removing forbidden cells from the neighbors lists, we're still checking them but just seeing that they are forbidden?
Yes, but then it will ignore them and not add them to the priority queue.
Okay.
So that is an option you can do instead of just not. You can add them all together and then go through and then change whatever cells you want to forbidden. The problem is that it will slightly increase the processing time because
that's what I'm thinking.
it will still check that neighbor.
Yeah. Is it not better if, like, at the time where we're forbidding cells, we sort of disconnect them?
There's two trains of thought on that. One, you can do that, and that way it will decrease the total processing time. The disadvantage is if you destroy a building, you need to relink them,
Is that
which means you will have to which means you have to either one, well, sorry, I'm thinking through how you could do it without start like scrapping everything and relinking everything.
which you were saying
Which
takes quite some time?
yes, it will take it can take quite some time. This but then the other was the other side is that if you were to just flag something as forbidden, it will slightly increase the processing time, but it will be, in my opinion, negligible compared to having to relink everything.
Okay.
Because that is going to take, because that will actually cause a frame skip or two,
Yeah.
in my opinion.
Yeah.
So, but what you can do is, if there is going to be terrain that is permanently forbidden, don't link them.
Mm-hmm.
If it is temporarily forbidden, keep the links, but it will still try to hit it, but it won't add that neighbor, which means it won't propagate through that that series of neighbors as well. So
Okay.
it still will help the processing time, but it's negligible impact, I believe.
Yeah.
So
The ocean and the islands disconnected from the mainland are obviously permanently forbidden. The tents, once placed, can never actually be moved again, so those would be permanently forbidden. Things like the
okay,
campfire, the drums, the trees, those will need to be forbidden but can be moved.
there you go. Yeah, so you just have to maximize the, how do I say this? My brain just does not want to change this abstract thought into non-abstract terms. Um, I think you already have it. I don't think I need to describe it to you, but essentially just do what you did, do what you said, and if it like you place a tent, it cannot be moved, cannot be destroyed. Like it is a permanent structure and nothing can happen to it. Then yeah, just delete the links.
Yeah.
Um, the fun part will be how you determine that
Right.
without an array.
Hmm.
Because well, there is a way you can do it, I just realized, but it has to do with the grid system that you create. So if you do like um, a dual numbering system, so like well, let's go with this. What is the maximum number of nodes by the maximum number of nodes? So what are the length of a column and the length of a row
Um,
in your current 2D structure
inside of a single cell or for the entire map?
for the entire map,
Um,
roughly?
hold on a second.
Sure.
There are. It's 512 nodes on the x-axis and 1024 nodes on the y-axis.
Ooh, thinking through this.
So we have a total of 524,288 nodes, which is why it takes a
Yeah.
really long time to draw them all.
So type something out here. So I would recommend something like this. You basically have an ID range, and you have your X first, and then your Y. So I mean, I'm sure you can kind of figure out where I'm going with this.
Yeah.
Is wherever you are at on the X-axis versus the Y-axis, that's the ID.
Mm-hmm.
Uh, I have the X in there because you need it. Don't need one, but some kind of delimiter between the X and the Y. You can put whatever character in there you want. Don't use a dash. I highly recommend you don't use a dash.
Okay.
But anyways, so if you were to place a tent, if you had an ID range like this, all you would have to do is basically go through and by adding in, like if a tent is a 3x3 grid, so to speak, you would just have to go through and by using the ID range, you could just add, specific numbers on there. So um, for I'm trying, man, my brain is just not here today. I may not stream today. Holy shit. Uh, Sorry, give me a moment to collect my thoughts on this.
Sure.
Okay, so I'll explain it as if it's like a 2D array, or in array, like the 2D array. So you have the X and the Y array or whatever, and you know how you have the two individual brackets for the 2D array to access the specific location in the 2D array.
Mm-hmm.
It'd be something very similar here, where you would just instead of incrementing 1 on the X bracket for the 2D array, you could just increment 1 in the third character of the ID. So, assuming if it was like just looking at the ID range, it would just go from 001 to 002 to 003, which would give you the X, coordinates of everything that you need to add, and something very similar for the 4D or for the other coordinate, the Y coordinate. God damn. So you could just basically go through and add 1 to using a for loop to each of the ID numbers, and you would be able to mark those as forbidden or do whatever operations you need to do in there to remove the links and whatnot. Instead of using a 2D array, is what I'm trying to say. You basically are using the general, how do you say, concepts of a 2D array, but you're doing it just through math and using a map. And it would be about the same speed, but you wouldn't have to deal with the 2D arrays because if you don't want to. I guess is the best way. That's what I'm trying to communicate. Did that make sense?
Um, what happens when you go beyond the third position, though? Yeah, I mean, you also it's like it still has the zeros in front. This is like how you showed me that you set up keys the other day, right?
Yes.
So
okay.
You can write it that way,
so
whilst keeping zeros at the front.
Yes. Let me do a real quick. Give me 1 minute here to write out a constructor. And if you wanted to, you could add this into the node itself, but I'm just gonna put something in here real quick. So ID equals the what is the substring version in GML? What String position? No.
I don't actually know what you're talking about, so I can't help you there.
Yeah, basically, there's a way you can pull out the ID or the numbers in the ID and to make it easier on you is what I'm trying to string copy. Yes, this is it. Okay. Copy. This is the string ID 0 3. Zero, 1, 2, 3, 4, 4. So, okay. I'm just use this as an example and then kind of let you figure out the further explanation after this. Essentially what I have here is when you create the node, you give it an ID. You give, and you pass it in as a string. So then that string you assign to, ID of the node, but you can also pull out the actual X chord and the Y chord as two separate two separate strings, and then I forgot to cast it as a real number. There we go. So what that does is that you will actually have a numerical designation of the IDs. So whenever you want to look to the, let's say, the right of the ID, actually write this one for you. That. Okay, I think that's right. So this will allow you can create a function that will be attached to the node. So you would, I assume you understand what I'm trying to do here with the constructor, with the function inside the constructor. Does that make sense?
I don't see it in the code. How the code correlates to what you are actually saying.
Okay. Yeah, because I didn't describe it yet. That's my bad. So essentially what I'm doing here is it will add 1 to the chord because it's in a number format and then cats it as a string. So instead of having to go through and do some calculations every single time you need to look around a node so you know what to make forbidden or change when you place a tent. You can set a function for the node so it will look right. It will return the string for the ID, and then you can use that string to find it in the map. So I can actually let me give you an explanation of how this works.
It's
And
getting the
code.
ID of the neighbor to its right.
Correct. And node map of And so, I meant to add that inside that. And then this is just kind of an example of how you would actually utilize that function. Because you have the node map, and then you would say whatever the current node you're looking at within the code .look right, it would just get you that immediately next right node and pull it out of the map, and then you have that node to work with. So you would just need to make a function for up, down, and left, or whatever directions that you want.
Yeah.
But by doing this, you wouldn't need a 2D array.
Right. Yeah, it's still confusing me.
Yeah, okay.
I understand what it does. I can't like make sense of how this code is doing that though. It's just I'm too unfamiliar with this. Like I don't understand.
Okay.
Like it's so. Yeah, no, I'm really struggling with this one actually.
All right, give me one moment here. Maybe I can let me do something that'll help. That might help. Pull up this. I hate their documentation. I really do. See a DS map create, because it just tells you it creates the map, but it doesn't actually give you an explanation on much. The DS map add might. Okay. So looking at that, the documentation for the DS map add, kind of looking down specifically at the syntax where it shows the argument, the type, and the description for the parameters when you pass what you pass into the function.
Yep.
So the ID is the map, so that's not what I want to focus on. What I want to focus on is the key and the value.
Mm-hmm.
And like I was describing before, you understand what the key and the value is, correct?
The key is the position in the map, and the value is what either what is stored there or what we're adding.
Correct. So, but you see that key has to be type string.
Yeah.
Okay. So whenever you access the map, you have to pass in the string. The function of that, look right, basically converts the number, the XY coordinates in there that is stored, and converts it into a string that you can then pass into the map to pull out the node to the right. And the reason why you want to add it into the constructor is because this is getting into OOP principles. Because you're creating like those, whatever the total amount is, the thousands of individual nodes, and instead of having to pass in the node each time, each individual node will be able to tell you what is directly next to it without a large amount of programming. Yep. This cuts down on processing time, I guess is what I'm trying to say in the end.
Yes, right.
By doing it this way, it will just be significantly simpler, and you will still be able to track your nodes easier, and it abstracts out a lot of the need to constantly, convert everything back and forth between numbers and strings in order to make it easier.
Right.
Because the problem with this fixes the problem of like you have the 000. Well, if you have 009, it will circumvent having to go through and check to make sure it's 9, and then you change, it over from 010. If you understand, I'm trying to say with the string manipulation there. But this just makes things simple, your life simpler in that regard.
Yeah,
so I hope I answered your question.
You lost me at the end there, but this is beautiful because what I always know is the first node. So like, if I have an object that is only one tile or one node in size, that's really easy.
Yes.
But yeah, anything larger than that, now I have. So this function uh, gets run on that first node and then looks at its neighbors, and we just have to tell it, perhaps based on the size of the sprite or something, how many nodes right to look and up to look,
Correct.
etc. Yeah.
Correct. And how you can do that is have a struct set up that you just pull for the size of that object, and it will returns back, the width and the height that you need to do, and you plug that into a for loop inside of a for loop, and then it just traverses it that
Okay.
way, and it just looks right to pull the next one out.
That's
So
really
there are
nice.
ways you can do that.
Yeah.
So yeah, well, you could also use recursion with this as well. Recursion might, well,
Kind of like a flood fill.
sorry, I'm thinking through the code of how you could use this. You could use recursion even if it's necessary. It's not necessary. Yeah, just use 2 for loops to loop through everything. Um, okay? If you okay, see this. This is a version of a linked list. The only problem you might run into, which you'll solve very quickly, I have confidence in this, is you just have to keep track of the node that you're looking at. So when you go through the for loop, you basically just have to have a variable outside the for loop that says what node you're currently looking at, and then you just have it look right and save the next node for the for loop in that variable outside of the for loop. So that way you keep track of the one you're looking at. Does that make sense? Because
I
you're
was
not
struggling to follow you there. Sorry. Go ahead.
okay. Think of a good way to say this.
I mean, you might even just be able to say the same thing again. I may have just kind of checked out.
I get you. Oh, I understand. Do the same thing. So basically, okay, I'll just go through it step by step here. You have the original node, the top left node, as I call it.
Yep.
You need to look at, but you need to look at the node to the right, and then to the node to the right of that one, and the node to the right of that one, if we're assuming 4 nodes.
Yeah.
So the problem is with a for loop, you don't have an array like you would normally look at and just pass in the variable for the for loop to loop through it. So you have to keep track of what the next node is, which then becomes the new current node of that, which I'll make that make sense here. So first iteration of the for loop, looking at the first node, set that to forbidden. Then you have the root node equals look right. So, and then it will pull that node and make it the new current node.
Okay.
Then you set that one to forbidden, and then you do the next node look right and set that one to the current node.
So it's
Then the
kind of
next
like
iteration of the for loop.
it's hopping across the
Go ahead.
nodes almost.
Correct. You got it.
Interesting.
You got it. That's exactly the terminology I was looking for you to say. And just keep in mind though, if you have multiple rows of this, you'll have to basically start at the trying to figure out the best way to describe this.
If you like reset and start from the left again, go down a row and
Correct.
yeah.
And go down a row. And I'm trying to piece through the best way to go down a row, because you're still going to have the original ID above. So you may have to. How do you do that? Because right now I'm thinking 3 for loops, and there's got to be a better way. Oh, okay. Basically, what you'll have to do is have an if statement inside of the inner for loop that you're traversing the rows, and you just detect that you've hit the end of the row. And you also need to detect if there is an additional row that you need to do. basically by checking the the outer for loop variable, and I'll let you figure that out. I'll show you that. Leave that as a puzzle for you.
Yep.
And then you go ahead and assign the new current node to the beginning of the new row within that inner loop. So then it will exit the loop and then re-enter the loop with the new current node, if that makes sense. So there are ways you can do it. It's just think through it. You got it. You now that you have the idea how it just hops across, you just need to figure out how to hop it to the next row.
Yeah.
So yeah, you'll figure it out quick if you have it. It's a fun puzzle for me. So I just threw a lot of information at you in many different forms. So now, what questions do you have?
Where do I go from here? Yeah, that is my question. I have no idea where I actually go from here now. My task, there's several things I could do. What I was originally working on was like first adding single nodes as forbidden, or adding is a bit of an odd term, forbidding single nodes, and then I was thinking of forbidding instances, whole instances next.
Okay.
But we've discussed about disconnecting nodes. That's an option.
Yes. So, okay, well, first we need to figure out, and I do apologize if I sent you down a wrong path here in trying to describe what Dijkstra algorithm was versus what you should have implemented, so that is on me. I do apologize.
Oh, it's fine, because
if you want to,
we would have had to get there in the end anyway, so.
Okay, but well, like I'm trying to get to is, do you want to get rid of the 2D arrays? Which means scrapping everything you just worked on.
That's a question I had earlier that I didn't manage to get out. Yeah, it's like, are those, because I was thinking of it like, oh, these 2D arrays are now only used in like the initial setup of the nodes, and then will never be touched again, which is probably not good to have some 2D arrays floating around that never get used again. Well, I can destroy them. I could
Not really.
Could just destroy them.
Not really. Like they may be useful later on. So it's one of those things where, I mean, you could set it up so that you don't need to use the 2D arrays, but I really suspect it might be useful later on.
Oh,
it's
no,
one of those things that a lot of programmers.
Sorry, I see. I see now why I can't destroy them. I was kind of thinking of other instances where I hold things in arrays temporarily and then use it to update something else, and then that array gets destroyed. But in this case, the array is the nodes.
Yes.
Yeah.
But if you, well, depending on what is created first. Oh god, I don't know how GML will handle that, so I'm not gonna go down that path. I don't want to confuse you. But to actually create the map to do this is actually very easy. It's just 2 for loops and just concatenating IDs using that the same general idea as that look right type thing. Just with the the I and J variables for the 2 loops, just kind of add them together, throw them into the constructor node function, and you have your 2x2 grid, but it's just in map form versus array form. So the structure of the actual map is technically just a list, which is, you think of like a 1 column list, but you create the pseudo grid or a pseudo array is probably the best way I can do it by utilizing the IDs system or something similar to what I'm showing you here.
Yeah.
So you can get away with using no arrays, or you can use the array as a way to create all the different nodes, and then you have a map that is separate that will still have the list of all of the nodes, and you use the array to loop through the list to connect everything.
It seems like
Programming. Yeah, go ahead.
it seems like we might as well forgo the arrays.
Yes, you can. It's just a different technique. Neither one of them is correct. Neither one of them is wrong. I'm just giving you all the information so you can make the best decision for yourself. Is kind of what I'm doing
I
here.
mean,
So
I guess it will simplify things ultimately, and perhaps I, I'm not sure in this case, but you've told me that looking things up in maps with keys is faster than searching through arrays, so maybe it also has some performance benefit.
there's pros and cons to both. Uh, when searching for something, a array is actually a little bit faster. If you're trying to directly access a specific spot or a specific node, the map will be significantly faster.
And that seems better than
So,
because we know where all of the nodes are. It's predetermined.
correct, correct. However, if you have some kind of uh, object, just in general, that you, as like a singleton or some kind of object out there that you need to know the location of, you can either do one of two things. One, search the entire map until you find it, which is a problem, or make sure you have some kind of other variable that's tracking that for you that you can just access it that way. So it does create the additional overhead of having an additional variable to track it, but you still have that instantaneous ability to access it with the map. So that's just, I'm saying that to keep that in mind. If you do have something that you need to track, make sure you track it instead of searching for it. You
I'm not
can,
sure what you mean.
okay. So let's see. I'm trying to think of an example I can give based upon what I know about your game.
Yeah, that's the thing because I'm not fully understanding you. I can't figure out what
Yeah.
this might apply to.
I'll just say it from a different perspective. Anything created in your game, you need to have a separate file structure tracking which node it is in. So that way you do not have to search the entire map to find that item.
Are we talking about
So, such
cells on
as,
the major grid?
I'm talking about like the characters, the trees, the tents, everything. You
But when
need
you
to have a
say
separate
node,
file.
you mean like a cell on the major grid, a node of the major grid?
Correct. Correct.
Okay.
Correct. I misunderstood your question. Correct. So essentially, you would have, let's say, an array of, or another map, if you want, of all of the characters that are going around the screen. You have a map for all the trees that are on the screen. So that way you can directly interact with those items instead of having to search the entire map of nodes to locate something, if that makes sense. You just always have to have some kind of separate file structure tracking items that are inside of each node.
Okay, this is where it gets completely insane to me.
Yes,
One thing is that
I can understand.
it does imply that things cannot cross the line and inhabit multiple nodes simultaneously. They can't be split between two cells on the major grid.
Uh, well, if you okay, like there is a disconnect here that I did not clarify. That's on me. So by doing the getting rid of the 2D array, you don't even need to worry about major grid or minor grid anymore
Wasn't the purpose
because
of that
everything
to
will just
optimize the pathfinding, though?
yes, which is the other part. So I was gonna swing back around to that. Um, the major grid and the minor grid will have to be in a 2D array. Well, not have to be. Could make a map for the major grid to do that. Oh man, this is getting in depth, and it's like I say this. How wide are your major and minor grids?
Oh, I
Sorry.
did. Well, hold on. I have some notes. Uh, okay, I believe this is correct. My major grid cells are each I'm not even convinced of this myself now. Let me actually look at the code. Okay, they are 16. No, I don't know what any of this means anymore. Let me figure that out.
You're good. Make a quick note from as I half hour past when I normally would start, which is fine. I'm just gonna let people know that I'm starting later.
Ah, no, I see what that is. My cells on the major grid are 32 nodes by 32 nodes, although the nodes are rectangular, not square. Oh, you were just asking about the width. A cell is 32 nodes wide.
Okay. So technically, you would have a 32 by 32 would be ideal, correct? For the node size, or for the 32 by 32 nodes for the cell size, correct?
It felt like a good size for them, yeah.
Okay. I mean, it's a follows the correct paradigm of bit and everything else. Uh, the way information is stored in memory. Give me one sec here.
And the major grid is 16 by 32 major cells.
So I'm just trying to figure out the best way I can describe a method that you could use. Um, you could do the same thing that I have described for the whole grid with the ID system you have there. You
Mm-hmm.
just have instead of make a change to what I have here. You have node to since you are calling them cells, you have cell ID, which is the major grid, and then you have sec. Trying to make your life as easy as I can with this. Um, and so you said 16 by 32?
Yes. No. 32 by 32. But it's just that they are differently sized.
Okay.
Vertically
Well, for the
compared
sake.
to horizontally.
Okay.
So
I understand
they're
what. Okay,
rectangular
I see what you're
cells.
saying. Gotcha. And then the other one. All right, so um, you can then again create a pseudo array inside of a pseudo array by using the same structure we had before. So you have your cell ID and X coord and Y coords for the cells in each individual node. Then you have the individual node ID. You will have to pass in two, though. Let me change. Let me make a change here. I just realized. Uh, Hopefully, this will make sense.
I think I gave you the wrong answer before because it is 16 major grid cells by 32 major grid cells.
Okay, so that's fine. It's yeah, easily changed just to that. Well, crap. Do do
And can't be that many nodes per cell, is it?
something like that. Well, I mean, well, just for the sake of argument, I mean, it still applies. We'll just, if you need to make your changes, you can make your changes.
Yeah.
But for the sake of this argument, let's just go with the 15 by 31 for the major and the 511 and by 10, 23 zero indexed for the individual total cells. So what you have here is you have your greater cells or your cells in your nodes. I'm going to try to use the terminology you were using. So when you're using, you will have to make a change to Dijkstra's algorithm to do this. Trying to think through the best way to describe this as I have it in my head how to do it. By using this grid system, you will have the ability to basically pull all of the nodes to be searched by referencing the major or the cells themselves. What you would have to do then is take all of those and shit, that's not going to work. There's a way you can do it. I'm just really having some major difficulty trying to describe it to you because this is getting into some advanced algorithms.
Is this something that would allow us to have instances spanning multiple cells? Is that what we're trying to solve for here?
Yes, actually.
Okay.
Because you're going to track everything with the node ID. So it doesn't matter if it is in a cell or multiple cells. Everything that will be placed, so you can just track through the node ID.
Mm-hmm.
The purpose of having the cells is just to delimit the number of possibilities that the algorithm will search through. The problem is that we are going to have to change the algorithm to account for this.
Okay.
So I'm just really trying to think of the best way to do this. I still think you're going to have a 2D array if you want to use the cell and node structure.
I mean, I just thought that was like, I thought we had to do that because it's going to lead to a performance increase.
It will. I'm just trying to figure out the best way to describe it and how to do it.
Okay.
Because it's, or a way, because I
And you are aware that it's adjacent nodes that would be used in pathing. I mean, you must
yes.
be. Yeah.
And I just for the sake of argument, it's only like the cardinal directions, like up, down, left, and right.
No.
It's not going diagonal at all. Okay.
It's
So
adirectional.
if it's okay. Thinking. Because the problem it has is that everything is still going to be connected to each other. There is, okay. Honestly, there's probably, I think I have it, but let me go hit the restroom real quick because that's gonna interrupt my thought process. I'll be back in like 60 seconds.
Cool.
But I think I have it figured out.
Nice.
There's two different ways we can do it, and I'll try to do my best to describe them to you, but I'll be right back.
Okay. Man, this is pretty crazy stuff. I don't even know where I'm going from here. I feel like I've been sent back to square one.
And I've just decided I'm going to get myself a rolling whiteboard because I could describe this so much better if I had a whiteboard. Holy crap. Okay. All right. So, are you there? You're muted. Oh, you stepped away. I can actually look at the screen. Hmm. Hmm. Okay, that is really the only way we can do it then. Which, okay, there is that minor problem. Then again, shouldn't be a problem. No, it will still create a problem. think a dual Dijkstra's algorithm is probably the best thing to do here. Decrease on total processing time. Dijkstra's algorithm for the cells, and then from the cell wall to the node.
Okay, sorry, just went to put the dishes away and wound up taking a rest stop
Oh, you're good.
myself. Okay.
Not a problem. I actually the two ways I thought the other one is extremely convoluted and will not work
Okay.
very well.
All right.
So basically the one I'm going to suggest is a dual Dijkstra's algorithm,
Okay.
and it's using the same thing. That's the beauty of it. It's using the exact same function. So essentially, what you're going to have to do, or what I'm going to recommend here, is you're going to have two maps, and you're going to have your node map and your cell map. The difference is that instead of, or for the cell map, you only have the border nodes in the cell map.
Mm-hmm.
And then you have the weight between those nodes as the number of, sorry, for the cell map specifics, I'm like referencing with cell map. Think that in code, with cell map. All of the nodes' weight is the number of nodes between those two nodes in the node map. So that way, what you can do is essentially do Dijkstra's algorithm from the node you are currently in within a cell to the closest border cell in the direction that makes sense. So if you're looking at somewhere that's northeast of you, you go north or east, depending whichever is closer. And then once you reach that cell, you do Dijkstra's algorithm to check the excuse me, to check the closest distance between the or the shortest distance using the cell, or using each individual cell. So instead of looking through the 200 or 300 or 400 cells or nodes, you'd only be looking through like 10 cells. If that makes sense.
Yeah.
And then you have the character move to whatever edge of that cell that you want, and then you just do Dijkstra's algorithm to the closest point within that cell.
Yeah. Well,
So
but
that
how do
was
they
kind of the
navigate through the cells in between? Sorry.
you
Because they still need to avoid stuff, right?
yes, and there is the problem that I'm running into. I'm thinking through it.
Yeah. That's why the original method was so good, right? Because we could find a path through all of the nodes, but only through the only through the cells that we would actually need to pass through, and we don't have to look at anything else, right? It was beautiful thing.
I'm sorry, I'm going through multiple things in my head here, trying to figure out like how to do this. I'm coming up with lots of them, but I'm like, that's way too much work. There's got to be a simpler way. There always is a simpler way. No, until you find the simplest way, but there is a simpler way. Okay. Oh, gee, this algorithm. Okay, there is a way. I think I have it figured out. And you're still doing what I just described, but there's an additional layer to it. When you have from the corner node, or from the edge of one cell going to the edge of the next cell, but you're going through multiple other cells. And since we're not going, traveling the way the crow flies, as in a direct straight line, the best thing you can do is go in an L shape. That is technically the closest way that you can get there. So, once you are going from the edge of one cell to the next, there's two things you're going to have to do. One, detect the direction that you want to travel. So, if you're going somewhere northwest of you, let's say 3 cells up and 2 cells right, what you can do is from the cell they currently are in, just keep looking up. So essentially, you're going to have to create a separate type of search algorithm. And if I'm really trying to break this down as simple as I can, so I apologize. So essentially, you just want to look in the cell above it, above the character. If that cell is free, look above the cell of that one. If that cell is free, look above the cell of that one until you hit the correct x-axis of the cell you're trying to get to. Does that make sense?
Mm-hmm.
So, and then you would do the same thing going to the right until you got to that cell. That assumes there's nothing in the way. That would be one of the simplest things you can do. However, if you run into a cell, you then need to see, okay, look to the right. If that cell's free, move right. And then you continue looking up. And if that cell is free, then you start moving up. And you basically do that. You just basically move in the best direction that you can until you get to your destination. And by doing that, theoretically, you should not ever run into a situation where you need to go. Oh, no, that's not true. I just ran into another problem with that algorithm. Basically, what if you run into a point where you hit a spot, you can enter from the left, but the other 4 directions have trees in them, or the other 3 directions have trees in them. It's gonna freeze right there because there's no way for you to back out and continue traveling.
Right.
So that is the problem with that algorithm.
Oh.
So, that's the reason why Dexter's algorithm is so good, is because it prevents any of that, because it automatically detects all that. And I'm just trying to figure out ways that we can basically utilize Dexter's algorithm to get the basic path there. Option 2, which is actually a derivative of the first one. Basically do something similar to what I said before, but you just do Dexter's algorithm within the cell itself,
Right.
within each individual cell. So you could go from the original cell to the edge, and once you reach the edge, you recalculate the shortest distance to the next edge using Dexter's algorithm. So that way, and then you would just keep doing that until you reach your destination.
Isn't the strange thing about
the
this that you can never, like, walk diagonally straight towards your destination.
Correct.
I think that's odd because in many cases that would be the shortest route.
Yeah, yes. That's the thing. That's the reason why I was talking about the. Okay, I may have. Okay, I think you may have misunderstood my question, or I should say, I did not ask the question correctly with the directions. So I was thinking that with each individual cell, the characters were only moving up, down, left, and right. If you are doing a diagonal, that does change things up a bit. Um,
Ideally, yeah, we want them to be able to move diagonally as well.
diagonally. Okay, so all right, so I was working under the wrong assumption here. That's on me. I didn't ask the question correctly.
I didn't realize either. I would have stopped you, spared you all of that.
Yeah. No, it's fine. It still applies to what I'm trying to do. I just add the four diagonal directions to it. I'm just trying to think of the best way to do it. Are you wanting to do an absolute straight line?
I mean, yeah, but that could. It's.
Okay.
I guess it's quite rare, but it could happen, and in that scenario, you'd want them to do that.
Yes. Okay, so this entire time I have been thinking of only accessing and walking on the grid north, south, east, and west.
Mm.
I have not considered doing a direct vector, as I call it, to the location, basically from one XY coordinate to the other XY coordinate in a direct line, like pixel coordinate on the screen. Um, I'm not. Hmm. Let me think through this a minute here. I'm trying to account for multiple possibilities at the same time with the algorithm I'm thinking of, and I keep running into, nope, that won't work. Um, that's one of the fun things about software engineering or just coding in general is how many times you're like, all right, this isn't going to work. It's time to pivot to something completely different. I'm not saying we're having to do that here. It's just leading down that path, but trying to think of what is the best way to do this, because there's a straight line. You don't want them to walk through trees.
Well, it seems like the straight line could get us pretty close to the cells that would be passed through, and then using Dijkstra's algorithm in each individual, well, through all of the nodes of the cells combined to get the actual path that avoids stuff. It's the original idea that we had, isn't it?
Yes, okay. There's one aspect I haven't communicated well that I need to communicate. The problem is that if we how we pull out what cells are where based upon the map, based upon this grid, this function node that I have here. How do we pull out the individual nodes within those cells and have them only be passed into Dijkstra's algorithm?
Mm,
That's the problem.
I
There
see.
is a couple ways they can be doing it, but it would be multiple maps and multiple ways of doing things. It is effective, but it is very convoluted.
Okay.
And I feel that algorithm, please don't take this as an insult, at your current level of understanding of how all this works would actually cost you more time in the end
Makes sense.
in development, just specifically. So I've been trying to weigh the options of development time, the cost versus benefit, development time versus the processing of the game. I've been weighing it the entire time. So that's what I'm trying to I mean, hmm. Because I mean, what I'm thinking of would take me a couple of weeks to do, and I understand what's going on.
If
So,
it helps at all, I personally feel I'm in a place where I'm willing to do whatever it takes to get the biggest performance increase possible.
okay, okay,
If I'm doing this, I might as well do it, you know.
yeah, okay. So, C++ would make this significantly easier, but we don't have pointers. We do have references, though, which are essentially pointers. Although it is kind of the way I'm thinking I would exploit the references the way that they're used in GML. The problem is future proofing it, because we don't know if they may change the way they reference stuff, and if they did, it would fuck you completely. Is the way I'm thinking of. It's one reason why I'm avoiding this one specific way that would be really what would work really well, but is exploiting the references and how they do it in GML. But I'm
Exploiting
specifically referring, yes.
makes it sound like
Um,
some kind of unintended way of doing something.
well, when I first started working with GameMaker, I went looking for specific paradigms of programming languages to see what it most closely mirrored. Um, and GML is built on top of C++. In C++, they have pointers, which is in itself a file type. And what you can do is have an array, and then you have a separate variable that is a pointer to a very specific position inside that array. And you can also have a pointer to the position within the array. There are numerous applications of what you could do this for. It's far outside the scope of this discussion, but it's just that is an example of something that can be done. Um, what I but GML does not have a pointer type variable. However, GML does actually save all of the variables, like an array or an struct, as a reference to memory specifically. And so, if you, just as an example, if you do a number, like you just do a var num equals 2 or whatever, GML actually stores that value at that variable. I'm really trying to abstract this out a little bit. However, if you make a struct, it will actually say the variable that you are saving is actually a pointer into the memory space where the values are stored in the struct, because a struct is a series of values. So it can't just save all that information inside of one location. It has to save the pointer to the location at the start of the spot in memory where that information is stored. Does that make sense?
Uh,
I can repeat it or say it a different way
yeah,
if you
yeah.
want.
Can you repeat that?
So basically, the way that computers in general store variables or information is there are key positions in memory, and those are dynamically assigned, and but they're saved as memory addresses.
Yeah.
The reference, or the whenever a struct is created, GML will create a spot in memory, get the first spot or the first memory address within the chain that is created below it for all of the other variables that are, that are basically contained inside of that struct.
Mm-hmm.
And I'll take that first memory address and save it into the variable itself.
Okay.
So whenever you access that variable, you're actually accessing the memory location directly that way.
Right.
So the variable is pointing to that spot in memory.
Yeah.
So that is what I mean by referencing.
Okay.
We can exploit that behavior by essentially creating a map, or let's say, let's start creating an array of all of the nodes, let's say. And then we can create a map that will then just add in each one of those array positions into the map. So we now have two ways to access the exact same piece of information, because unless you tell GML to make a what they call a deep copy or a exact replica of the information, GML is just gonna be pointing to the same exact spot in memory, the same memory address. Does that make sense?
Yeah.
So we could, in theory, exploit what I just described as having multiple maps where you have the greater, I'm going to call it the map of the world, if you will. It has all the nodes in it, and all those nodes are connected to one another. Then you can have a map of all the cells, which will then, have all of the edge, the nodes, as I was describing before, all inside of that one. So the cell map is significantly shorter than the world map. And but both of those maps are still connecting to the same spots in memory of the individual nodes.
Interesting.
So essentially, you're referencing the exact same memory location, but in just two different ways, and one map is smaller than the other. With the smaller map allowing you to be able to traverse using Dexter's algorithm to smaller points to get there. Um, uh, so far, does that make sense?
Yes. Yes.
But I haven't gotten to the advantages of this and disadvantages. That's okay. I just wanted to make sure you understand the concept first before I really start diving into it.
It's like an overlap with the edge nodes in a way.
I'm not sure I would describe it that way, but I understand what you're. I think I understand what you're trying to say.
If they're both pointing to the same thing, I kind of
Yes.
imagine that
Well,
as some overlapping.
Yes. Well, technically, yes. Yes. Okay. Yeah. Yeah. Okay. I see your perspective on that now. All right. So how do I describe the benefits of this? And how does it marry for shorter processing time? And how do you use it to find the shortest path? So, with the assumption you find the shortest path through the cells first. So now you have Dijkstra's algorithm returns all of the information or that path through the cell. So you have an array of that path.
Mm-hmm.
So what then you would have to do is basically run Dijkstra's algorithm through every single one of those cells.
Yep.
Individually. And as the character there's two ways you can do it. One, you can do it all at once. I wouldn't recommend that. The better way, I think, is when the character reaches the edge of the cell, just redo Dutch algorithm at that point, just in case something changed in the cell. So it reduces the possibility of having to redo it anyway. And you could have the character, try to whatever the shortest path is from the new source node to the new end node, which is the edges of the cells. So that would actually decrease the total amount of time, the total processing time, and would account for anything that is in the way. There are some extreme edge cases on this, which let's discuss those after. That would possibly occur, and ways we can mitigate it. But by doing that, I'm going to say the dual reference system, it's just that the difference is you're looking through fewer nodes to try to find the general path to the destination. It does dramatically decrease. Yeah, okay. That is probably the best way to do it. Is kind of how I described, and still using that dual reference type system. I still have a fear that they may change how referencing is done in the future. I haven't seen any roadmaps or have any knowledge that they will, but if they do, you will not be able to update GameMaker Studio until
I'm not updating it already.
If they do that. Okay, so you're doing the same thing I do.
Yeah.
Like I have something, it's working, unless something is really broken, or I really want a feature, then I don't update. So okay, so we can now, okay, with that we can put that the referencing thing to the side, or the fear of them changing that to the side. That's good. Okay. So, and by doing this, it actually, I mean, it's a very minor amount of memory that would be utilized by having this dual mapping, dual Dijkstra algorithm type system. It is slightly convoluted though, but I think based upon what you have responded with, you kind of have a general idea of how it will work. But you will have to add some minor pre-calculations in. What I mean by pre-calculations is you'll have to see what cell you are in, what cell you are trying to get to, and then determine which side of the current cell you want to go to in order to reach the edge of that cell to begin processing for the next cell.
Okay.
If that makes sense.
That's all fairly straightforward.
Yes, I guess I'm just trying to cover all bases here for you to make sure that you're as well equipped as I can possibly get you there.
Yeah. I think the point of confusion for me right now is the cells they have like multiple edge nodes. They have all of the edge nodes. Is that correct?
Correct. So so you have two options here. One, the simpler option, however, gameplay will be a little more clunky in this regard. You just have the character go from a middle point of the edge of every box. So we know the center point of the edge of every box to the center point of the edge of the next box or cell over. And then that way you're only tracking 4 nodes per cell, per larger cell, which would dramatically decrease the overall Dijkstra's algorithm processing time. Or you can have every single border cell on the cell in the map for the okay, what's the best way to describe this? Basically, you just have every single border cell in the map for the cells, but you have to do individual weights for every cell as you connect them. And the problem with this one is you're going to have to basically connect every cell to every border cell to every other border cell in some way. So I wish I had a whiteboard here. It sounds more difficult, but
Is that every other border cell on the map or every other adjacent border cell?
Every other adjacent border cell.
Okay.
Well, hold on. No, I'm wrong. I just realized I am absolutely wrong on that. Give me 1 sec here to think this through. Okay, we need to take 1 step back. How do you plan to adjust the character movement, assuming there is an obstacle in the way between the start and the finish? Are you going to... Hold on, let me think of a better way to ask this question. So basically you're going to have the characters go from the source XY position on the map, the actual room. I'll call it the room, so that way we can separate terms here. To the destination XY coordinates in the room, and you're wanting to test every single node that it touches in between to make sure that's going to get there.
Yeah.
And then the best way to go around it. So I just came up with a better way to do it. And you will still use the cell methodology, going from one cell to the next. But I'm trying to think of the best way to do this, but okay. This is going to be actually faster. And we're breaking it down, and you can make the adjustment in each cell that it passes through. Okay, currently what I'm thinking of is, instead of using Dijkstra's algorithm from the beginning, we basically detect, by just using standard math, the straightest all the cells in the straightest possible line to it, and detecting every single one of those nodes without using Dijkstra's algorithm, and just seeing if there's an obstacle in the way. If there's not an obstacle in the way, the character just moves. without ever using Doctor's algorithm. I'm just trying to figure out the best way we can do this. And that will actually work. Holy shit. You will still need Doctor's algorithm if there is an obstacle in the way, but if there is no obstacles in the way, you should just have the character go straight toward it, straight toward that cell from one cell to the next. That is the best case scenario. Then there is the median case scenario and the worst case scenario. And by doing this type of scenario system, it will decrease, it'll be an overall decrease in processing by even more significant margin than Doctor's algorithm. I literally just realized this. The question would be, what is the best way to look at each of the individual nodes along the path, the direct path to get there?
Yeah,
And that would all, go ahead, go
I
ahead.
had a concern that what if one of the nodes along that path is like completely blocked?
Okay, yeah, that's the median case scenario. And
Okay.
there's a worst case scenario where we have to literally circle the map type of thing in order to get to point B.
Yeah.
Which then it would be a very heavy in processing. However, it's a rare case
Yeah.
and should not really be that big of a deal.
Right. It's
They call it an edge case, and it's things you try to account for and do the best to mitigate, but you're not going to be able to mitigate it completely. So essentially, what we would probably want to do is I'm just going to kind of talk through the algorithm, and then we can break it down. First, take the XY coordinate of the character location, the XY coordinate of the destination, and draw that straight line. And then check every single one of those nodes that line would touch in that straight line. And how you can do that is based upon, XY, the XY coordinates in the room, and how it directly will correlate to the individual node. Because the nodes will have laid out in their grid pattern, you can very easily do a, division of the current X coordinate divided by the number of cells in, if you're thinking X coordinate and the horizontal line. And that will give you the cell that it is currently in, and the same thing for the Y. So you have your XY coordinates in the grid just by doing that coordination. And then as you move toward, use a point direction. Okay, hold on. This is some trigonometry here. Math is fun. That's how. Hmm. Problem is that the angle is going to change the distance you cross boundaries of nodes. So I'm trying to figure out how to account for that. Because you absolutely want to do it this way to start. Because you will save a significant amount of processing time by doing this. Because simple math, or just, simple to computer, the math calculations are simple versus trying to, do searches and everything else. Because the way the processor works, but I'll get into that. Best way to do this. Point A to point B. So it crosses through. Wow, this is gonna get involved. Shit.
Still manageable, do you think, or is it not viable?
Oh, it's viable. It's extremely viable. It's just I'm trying to come up with the expression for it, the mathematical expression for it, in code format, specifically in my head. And this is definitely a point. AI would probably be ideal to figure out the expression. But essentially, we need to get the distance between the 2 points, the angle between the 2 points, determine the length of the line when you traverse each individual node. Problem is that it's not going to be the same traveling between each individual node. However, it would do a just edge cases to that scenario. Sorry, I'm not being descriptive in what I'm thinking because it would take too long for me to describe what I'm trying to do in my head here. I apologize.
I think I'm with you so far based on what you said.
Yeah, essentially what it is that if you like imagine, the grid in your head and you in any 2 points and then you draw the line between them. As the line traverses through all of the grid, all the boxes of the grids, the length of that line is going to be different from one box to the next. However, in 90% of the scenarios, it's going to be one of two lengths or length of a line. So you'll have like a smaller length and a longer length, and the smaller length and the longer length. So so you could, every other grid detect it that way. I'm just trying to wonder if there's a better way to do this, or if there is a, let me do some quick searching here. MP grid math. Are you serious? That's what you're already using, right?
Yeah, I've been using MP Grid.
That might be useful here for this. No, not what I thought it was going to do. Okay.
There are potential steps, MP potential step, which sounded somewhat like something you were describing earlier.
P. Potential step. Function is an instant to take a step towards a particular position. Define.
So perhaps, I mean, without doing anything drastic, a simple optimization would be to take potential steps up until the point at which you need to avoid something. Well, is that even necessary? Because it does avoid stuff. It might be better than making paths, I don't know.
Yeah. The problem is that it like returns. Okay. Hold on. The function instance step size, the speed the instance moves in pixels. So it would per step. It doesn't account for future obstacles, is what, and that's one thing I'm trying to account for. Because essentially, we need to figure what's the best way to detect all of the grids it will pass through, or the nodes it will pass through in the grid, going directly to the destination. There's that possibility. Oh. Sorry, I'm cooking here. Give me a moment. I'm trying to create a. Okay, I have an idea. Okay, this might actually work.
Hit me with it.
I'm trying to figure out one last part of it in my head, an algorithm for it, which is based on the grid. Okay, that's how you do it. All right. Basically, we need to figure out how to look at the next cell or the next grid. Okay, look at the next grid specifically. Okay, node. That's the term we're using. Node and cell. The node is the smaller ones. The cell are the large ones. Okay. Looking at a node, and you need to figure out which node you need to look at next to determine if there's an obstacle in the way. What you can do is get the the distance between the 2 points and the angle. So essentially, you look at the, I'm trying the best way to describe this. You take the point distance between I have it in my head. I just can't pull it out and put it into a way that's easily described. Sorry, my brain locked completely there for a minute. So thinking from the center of one grid to the center of the next grid over, with the angle in mind of the line going from point A to point B, if the distance to the center of the next grid over in the direction you're traveling is less, hold on, it's not the center of the grid, it's the edge of the grid, of the node, excuse me, the node. So if you're traveling from the edge of one node going along the diagonal line, shit. I'm the algorithm in my head. I have it. I just can't put it into words. Crosses, it will go from short to long, short to long. Got the edge cases. Oh, wait, this won't work because you have the, because they're not squares, they're rectangles, right?
Yes.
Shit. Okay, never mind. That's not going to work. Still thinking through. I'm sorry. Problem is, it's just it's the straight line instead of like going like in a checkerboard type pattern. Because that's the assumption I had been going with this entire time, that it's going through a checkerboard type pattern and not straight line. But I didn't ask the appropriate question to get that, so I'm trying. racking my brain here. You can do it. I'm just trying to figure out the best way because the problem is the rectangle, which I understand why you're doing it that way. It's not a problem. Um, Without having to pull. It's not coming to me. I detect it. I mean, hi, buddy. You get fed in 20 minutes. Damn, I realize it's almost noon my time. Okay, one of the problems I'm having trying to figure this out is short of detecting every single pixel along the way as you traverse that straight line to see what grid it is in, which is not a good idea because that would completely uh, eliminate what we're trying to do because you're going to have just as much processing power doing that.
Yeah.
So do they have? Does we can kind of cheat here? Let me see here. And I found something that was from 2017. Okay, this will work. um, you'll have to use that. Okay, I'm going to describe what it is and kind of in general. I think you'll figure it out pretty quick. Uh, Using the collision meeting, like using collision, actually, we can draw a straight line and then move along that line and like stepping. Um, okay, yeah, this will work. You will have to enable collision on objects by doing this. Instead of just going solely by whether or not there is a object in or some kind of data that says there's an object in the node. By doing this, you'll need to have some kind of collision added to each object, and like the sprite mask as an example.
Yeah, that's already
And
set up,
we
so
draw.
it's easy to do.
Okay, so essentially, what we want to do is draw the line starting from the point of origin to the point of destination. The width of whatever the width is of each individual cell, you travel along that line in steps, and if you hit it with, and then you do collision or do what is it, the uh, position meeting at those coordinates. Nothing there, go to the next one. Nothing there, go to the next one. And what this will do is ensure because you're going to be starting in the middle of the cell
Not
or the
necessarily.
grid. Not necessarily. Okay.
They could.
I would recommend. Go ahead. Go ahead.
What happens sometimes is that they're like midway to, along a path, and then they cancel their current task and switch, and then they're pathing from a place where they're not sort of snapped to a cell.
I would, for the purpose of one, this will also decrease your processing time, or your overall processing. They can only make that decision when they reach the center of the cell. So if they do decide to make a change, they will continue to move to that location and then, do their processing or however you want to do it to make them switch. That will ensure that one, you're not constantly checking everything all the time on every character to make that kind of decision, which will again help processing. And two, it will help with the pathing because if it's going from the center of the cell and you're moving along, regardless of the angle of the path or the length of the path to the new destination, and you're checking to see if there's any objects in the way, and you're stepping with just the width of the cells, you're guaranteed to hit an obstacle or hit a cell with an obstacle in it. And if there is an obstacle in the way because of the way that the angles and how everything else works, the only caveat is that you could do a step and hit the same object. So you will need to check if you want to detect all the objects along the way. But anyway, so let's just assume you see an object that's going to stop. And then from there, you can either one, move toward that object, or use Dijkstra's algorithm at that point to try to find the best way to get through that individual cell.
It's just I don't think we can do that because some interrupts need to happen instantaneously, like combat.
Okay. Okay. Well then that's out the window. That's fine.
Unless, we would need a system by which they are always pathing to the center of the next cell along their path, so that it could be done at that time. But that kind of, I'm assuming that kind of defeats the purpose, though.
Yes. Yeah, you're right. You're absolutely correct. It could still do it. No. The problem is that it could be at the very far edge, and then when it shifts, it could jump right over cells at that point.
Okay.
Actually, it could jump over other cells even with the other way.
Oh.
But the best way to do it is the stepping thing.
Stepping from one cell to the next.
Well, looking along that line in steps, instead of checking every single pixel, you're checking every fifth pixel, let's say.
Yeah, okay.
And then as soon as you do have a collision, at that point you'll want to jump into the Dijkstra's algorithm.
For some reason I'm not a huge fan of this idea, just because it's like,
okay,
I understand it's definitely, I can totally see how it's more efficient, but it's like this weird hybrid of just moving in a direction and then switching. And then switching into actual pathfinding. There's something I don't like about it.
No, I understand. But you're absolutely correct. It's
like unpredictable behavior.
But...
You know what I mean? It's like they have two different styles of movement, and they're going to be switching. One style of movement is like they're always moving on a grid, and the other is suddenly they're just like free floating, and they're just sort of floating in free space, which to me is weird. It's probably kind of some sort of OCD tendency that I have that kind of irks me.
No, I got you. So then the question would be is how do we... Ooh. because I was assuming everything was in the four directional path and not a direct line, we are actually going to run into a very major problem.
What's that?
Okay, we found the best node path to the destination, or the best path using the nodes going to the destination. How do we traverse that?
How do we traverse? Well,
Wait,
when I started thinking about
shit.
that, I was thinking like we take the next node and the current node and find the direction and then increment our speed by speed per step in that direction until we hit the next node and update and rinse and repeat. I think the
Yeah, the
beauty of
problem.
the built-in pathfinding is probably that it does longer stretches, like it's aiming at some point several cells away rather than having to do it every cell, which is how I'm assuming we'd have to do it with our nodes. Now I think about it.
Yeah, because the problem I'm having is if you want to have everything going in a straight line, you have to account for the nodes in that straight line.
Yeah, it's like every node is a point on the path, isn't it? Rather than it kind of grouping them.
Correct. So I'm beginning to wonder if what we've been discussing is even feasible. From the beginning of this discussion, from the very beginning, if it's even feasible, because I have gone with the assumption incorrectly of uh, the four cardinal directions. Because that's the reason why I asked that question in the very beginning of, is it north, south, east, and west, up, down, left, and right? Because I did not ask the question appropriately.
No, I definitely said that they move diagonally as well as eight directional.
Yeah, directional. Yeah, I misunderstood it then. That's on me.
But part of me wonders just how much of a performance increase would I get using Dijkstra's algorithm on just a map full of nodes without chunking them into cells.
Very little.
Oh, I see.
That's the reason why because without it. I, I I'm cooking with something here. Sorry. Ray casting. Hold on. Problem is, it can from any pixel to any pixel. Uh, so that's just Pythagorean theorem. All right, I need to get a piece of paper for this. Hold on. All right, so I'm just drawing something out here for my... Come on, pen, really? There we go. Okay, so you want to go from here to here. And we draw a line through this. So, okay, that's a good sampling. Shit. That's not gonna work. The problem is because we want to do the straight line, I don't think diagonal algorithm is going to work because it assumes you are traveling along the weighted lines with Dijkstra's algorithm. And that's the disconnect I have. I'm trying to marry two different paradigms together and you can't do it. So since everything is going in straight lines, Dijkstra's algorithm can't really be used.
Why is that?
Because you have to travel along the... How do I describe this? I'm still doubting what I'm saying. I swear you can, but I can't find the answer. That's the problem.
I mean, when we're saying straight lines here, what do we mean exactly?
The shortest point, but the shortest point as the bird flies, between 2 points.
Well, then I mean I don't think we're talking about the same thing.
Okay.
Like a straight line path would be taken, for example, if your x coordinates were different but your y coordinates were the same, right? You would walk over to that thing in a straight line.
Yes.
There's also a version of that diagonally where you walk in a perfect diagonal line if there's no blockages along the path. But
yes,
anything outside of those 8 directions, you have to zigzag a lot. You wind up doing some weird shapes because you're still on a grid.
Yes. Okay, well, let me ask you this. Are you okay with them zigzagging if they do that? Or do you...
That's exactly what I was expecting. Yeah.
Okay. All right. So, again, I misunderstood what was said. All right. So, if that's the case, then yeah, we can do this differently.
The straight line that you were talking about is the thing that weirds me out because they're like off grid. They're going rogue. It's like crazy.
Yeah. Okay. Yeah. I think this may just be it was a miscommunication. I misunderstood something you said, and I asked the question incorrectly. So everything is going in one of the 8 directions. Then Dijkstra's algorithm can absolutely be used. Okay. So okay, now, yeah, let's revert back to where we were before. Jesus Christ. No, it's fine. It's fine. This is one of the beauties of coding, is especially between 2 people. Like, you and I really haven't worked together before, so we don't understand, really figured out how the other interprets things.
Yeah, it's funny.
Which is fine. It's standard. So I just drew out like a fairly grid system here. So you're trying to go from here to here. There will be some crazy zigzagging, but it can go in the 8 cardinal directions.
Mm-hmm.
So with that in mind, boy, that's going to be fun to connect. Actually, it won't be too bad. It's just a for loop of a for loop of a for loop. But then again, you're loading it, so that's a one-time load. That's fine. That's fine. So the hangup we currently have. Okay, so let's digress back and restate our understanding of what was working before I completely diverted us in a different direction here. So we have 2 maps that we created. One is the world map, the one is the cell map. The world map contains all of the possible nodes laid out in the room that we're working with in GameMaker. Well, the cell map is that 16 by 32 grid that contains, which is basically just a abstraction out of the world map for easier processing in which direction we're going to travel.
Mm.
So the world map will contain. I'm drawing out like a crude one here to try to give myself a better visualization of what I've been trying to do here. And they can go in the 8 cardinal directions. So that, and we're trying to get from, say, this point to this point on my little crude little map here. And we want to travel in the straightest line possible, but we can zigzag. So, what I believe is probably that will prioritize diagonal first. Dexter's algorithm will traverse the entire thing. So if we have the point, if we just do the greater grid, or the cells, just the center point of the edges, that would work.
Okay.
Since you're okay with the kind of zigzag line, it will still be the quickest route. So, within the cells themselves will have the 32 or was it 16 by 16 nodes.
I have a possible concern with that. I'm not sure if it really applies, but what if the center cell was blocked?
That was one of the edge cases that I was going to bring up on how we could address that.
Okay.
And it would create some minor variation on how we would want to handle that, and there are a couple of ways we could bring that up, but let me write that down. Center blocked, or even better, I mean, there's still going to be a possible situation where the entire side, if you were to do like all the edge nodes or whatever of that cell, and put that into like a map contained for that cell, there's still a possibility that all nodes on one side could be blocked. So there's still
True.
that possibility.
Yeah.
Um, so what we can do is there's a dynamic processing and a permanent processing. Dynamic has to be done because the trees can be cut down, right? The
Yep.
trees can be cut down.
Well, the
So it
tree being
has to
cut
be
down
done.
isn't the problem. It's the player can move them. The tree being cut down leaves the tree stump anyway.
Oh, but can it? Can the player go, or can the character go over the tree stump?
No.
Okay, so that actually
But
saves that problem.
the trees can be moved by the player. That's that's the thing.
Oh, because you're God, so you can actually pick up the tree and move it to a different location.
Yep.
Hmm. And at that point, will that the spot that it was removed from be traversable?
Yes.
Okay. Keep that in mind when you're figuring out how to make all the connection in the maps, which there are things you can do with that, but let's focus on one thing. Oh, actually, I just realized the way that could be done dynamically. Okay. So, okay, focusing just on the tree or the cells itself. So, uh, we'll need to just put the edge case to the side, or the case to the side where we have, you know, something in the center there. Let's put it to the side, assuming that all of the grid uh, edges with the one centerpiece are free along the way. You could just have it go directly from, one
Side to the
center
other.
to the other, to another edge of the center, and you keep going that way. That will still give the illusion of it going in a straight diagonal line, because it will stay within that diagonal line, assuming, going up to the general location, assuming no obstacles in the way. And then once it hits the x, y, or whichever it hits the x or the y axis first, um,
Are we going to
it will then
have
travel along that. Go ahead. Go ahead.
Are we going to have corner nodes? Because that kind of gives us full 8 directional support, that they could go from the
Yeah,
bottom left
that'll
corner
work.
to the top right corner of a cell.
Yep, that'll work.
And
I mean,
so,
I was just going through a thought experiment and trying to make sure that this is viable with what I'm wanting to do. But
yeah,
yes, that would work too.
that would be pretty cool.
Um,
And so you're saying that if the cell is completely empty, we just default to going to the opposite node, basically.
Correct.
And there's
So
no need for
yeah.
any pathfinding, essentially. And how would we do it without? I mean, do we just give them like a speed and a direction and just send them off without doing any pathfinding?
Two options. Well, one, you will want to create a constructor of that would house all of the information for each individual cell. In there, you will want to have how many trees you have, how many other people there are, or whatever obstacles are in there. You could just say there are this many obstacles
Okay.
within that cell. And the first thing you do when the character reaches that cell is check, are there any obstacles in the cell? If not, go to the, whatever direction that we send it to.
Yeah.
And that would just be very simple how to do. You won't need to do any detection from one side to the other side. Unless you like pick up a tree and try to put it in its way or something like that. But there's
Everything has
something
to
we
be
can do.
recalculated then.
Yes, but you can there's things you can do how do I say? I guess the best way that they're called or something like that in GML is like set an alarm or set a there's a programming concept called listening
Yeah.
and observe like there's observers and listening and all this kind of thing. So you basically have it set where every frame the character will see if there is an action being done inside of this cell, and if there is, it will do the recalculation then. If there hasn't been some kind of action done inside this cell, then I don't do the recalculation.
That's better than
Um,
running it on
and
everything like I do now.
correct. And basically, what you can do is a real easy way to do this is if the mouse is inside of this cell, it you can have the character, you know, once every 60 frames, do a recalculation.
Why is
So
that
that way you're going
necessary?
to
I know when it's been modified, so we only need to do it once at the time of modification, right?
correct. I've just yeah, that's a better way to describe it. I was just trying to think of a way to I check all. So if something happens well, anyways, you figured it
Yeah, it's because
out.
there's nothing outside of the player's control that would be doing that, so we know exactly when it's happening.
Cool. Well, if you have a detection system for that, perfect. Yeah, and at that point you would just set the flag, have the character do the recalculation, and then change the flag back to
I mean,
not observe or
I don't even have that. It's built into the like drop function. When I drop a tree on the map, I know the navigation grid has just changed. So with all creatures, I end their current path and recalculate pathing.
and a really good way to do that is basically so instead of recalculating them all, you just get all of the information, or you have each individual cell track
Who's in it?
what who's in it, and then you just have them do the recalculation versus everybody else
Yeah, much
all at once.
nicer. I mean,
So
that was never a cause of performance issues, really, because it happens so infrequently, and yeah, but it's still much
but
nicer.
well, the problem is that if you have enough on the screen where you do an action and you have frame skips because it has to process them all. So it is a fairly rare occurrence, we'll say. The problem is
Yeah,
every time you have to do something, it causes a skip. That's going to annoy the piss out of the player. So you
yeah.
still want to try to make it as minimal as possible.
That was actually what was happening with the Miracle Forest, which creates a bunch of trees. I was I was canceling and recalculating pathing for every creature for every tree that was created, rather than just once after all the trees had been created. That was bad.
Yeah, the best thing you can possibly do there, in my opinion, is set a flag that those like creatures will check to see if something has changed instead of on a creation of every single one. But I think you figured that out.
Yeah,
So it's significantly faster for the processor to have every single one of those characters just check like a global variable as an example, than have everything redone on every possible other event. So that just creates this a complexity that's far beyond anything that you really need. But you have
yeah.
figured that out, so I'm just sorry. I'm in my professor explaining note here, trying to explain to everybody else that's not listening.
No, that's quite good.
So,
That's quite good. As soon as I'm live, so
okay. So, but yeah, basically, whenever the character moves into that cell, you just check the cell. That character, the function there will check to see if there is anything in there. If there is anything in there, you can pull the list of nodes with objects in it. And that's the best way to do this. So what I'm suggesting is a hierarchy system of increasing. Okay, going like it's a step system. So the first step is seeing if there is any obstacles in there, and if not, move to the next area. Automatically, there's no problems.
Yeah.
If there are obstacles in the way, um, or possible obstacles in there.
You know what else you could do?
Uh,
Sorry, you could do a collision line across the thing and see if there's anything, and just if you can walk in a straight line, just walk in a straight line.
that is a better thing than I was thinking. Yes, collision line. So we have check obstacles, move, collision, move. If there is a collision line in the way, at that point, just use Dijkstra's algorithm. It'll scan the entire cell, but you'll have the best line. But you'll have the best way to do it, and it will. Um, hmm,
So, yeah, I'm taking notes. If there's nothing in there, you just walk across. If there's something in there, do a collision line. If you don't find a collision,
mhm.
Dijkstra's algorithm.
Yes, but you're going to have to make a slight modification to Dijkstra's algorithm because we're wanting it to go to these corner nodes or the the edges or whatever of each of them. You basically just let me actually so I can put this into the code for you where you would need to do this detection. Basically, you just want to see what direction are you traveling. So under the Dijkstras, um, okay, actually, I'm gonna go hit the restroom real quick because it's starting to impact my ability to think.
Yeah, I'll grab
But
something to drink.
okay, I'll be right back.
Okay.
I am back, and I just realized something real quick about something else. I'm gonna write this down real quick. I can, in the series, are you there before I start talking? Yeah. Oh, yeah. Reload player. That'll help. Hmm. Okay.
Okay, I'm back.
I help if I unmute.
Thought you might have forgotten.
Oh, shit. Okay. Well, the final piece of this puzzle is, okay, of course, to kind of reiterate, one, see if there's no obstacles. If there is one, check the collision line. If there is a collision line, then we go on to Dijkstra's. The question is what is the exit node out of the cell?
Ah, good point.
And I'm trying to, that's, there is a way we can detect that. And essentially it's, how do you say this?
Well, there is
I
only
do have an
one
idea.
potential exit point depending on the next cell, no?
Well, the problem is, you're right, because of the quickest path, because this is assuming we've done a Dijkstra's algorithm on the
Cells.
major cells to get to the next path. So yeah, you're right. You will have the whatever the next cell is, and you just got to figure out which one of those nodes it is. So yeah, you have it. And then once you actually enter in the cell, you have Dijkstra's algorithm to that point.
Right.
Or doing the same thing, it's just to the point. So those three cases. So
I'm not quite sure
all right.
how I figure out which node it is. But yeah.
There is a way. It's actually fairly simple. You basically will have you find it using the neighbors. So because each of the cells will have an array that has all the neighbors in it, or a map that has all the neighbors in it. What you could do is whenever they enter that cell, you take out the pathing, whatever the next cell needs to be in that pathing list, and and then you just do Dijkstra's algorithm, and it should I'm overthinking this. You'll have the no. It really depends on how you are saving the individual nodes in the. Okay, sorry, I'm thinking out loud here. I apologize. I'm probably going in circles here. Basically, whatever the neighbor or you're going to be tracking those nodes anyway. You're going to have all 8 of those nodes. What you need to have is a list of the 8 nodes that are, or 1, 2, 3, 4, 5, 8 nodes that are on the borders that you're using kind of as the access or the connection nodes, if you will. A list of those and whatever other node they're connected to in a map. And so whenever you enter this cell and you need to figure out which one of those 7 other points you need to connect to, you just take the ID of the cell, put it into the map of those 8 nodes, and it will give you back the exact node that you want. And inside of that node, you'll have the XY coordinates for them to move. If that makes sense.
Sorry, I just got caught up thinking about the nodes are on the connecting line. They're like right on the edge. Is that correct?
That's kind of how I envisioned it, but
okay, that's
but
weird.
I mean, do your own Oh, I see what you mean.
It deviates from them being on a grid. Suddenly they're like on the edge of a cell.
I see what you're saying. Okay, yeah, yeah. You know what? I think you got it. I think I may be confusing you here at this point because I'm conflating things in my. Oh,
I'm
I
well.
see what I'm
I'm
doing.
not even sure if the um would the edge nodes of the cell be inside or outside of it? Inside?
I see your question now. I have it as
Do I walk up to the outside edge, or am I actually stepping over the threshold into there? Or
so
is it best to have it on the line? I can't really decide.
well, you would have to. Oh, if we did want them to actually move in a uh, diagonal pattern and not like step over one node and then continue walking in a diagonal pattern, stepping over one node uh, or up one node, we would have to make it so that the cells actually go through the center of the node. Which what this means is that one node can be in two cells, and which isn't a bad thing. It just means that that is a connecting node between the cells. So when it enters that connecting node, um, you will automatically know, or best way to describe this. It's like a doorway going from one room to the next. You're just walking through the door. That cell or that node is a doorway into the next cell.
So it would fall on the
And
line. Is that right?
shit, that is a bad explanation.
I
I'm
can't.
actually, I mean, yeah,
How can it be in two cells at once unless it's basically on the line connecting them?
correct. That's what I'm trying to actually piece through right now to see which one is a better option for you. Um, because if you have it where, I guess using the door analogy, the wall is separating the cells, and you walk through the door, you go from one cell to the next. That would mean that you have the line between the cells would be along the line between two nodes, um, and you would have to connect those two nodes together next to each other, which they're going to
Right.
be connected anyway, so that's not a problem.
So
It's
the
just I'm trying
edge nodes of a cell would be inside of the cell.
under this scenario, yes,
Yeah.
and the problem is, at that point, we don't have the 8 cardinal directions.
Wait, why not?
Um, well, not necessarily.
You should still say it's the bottom center node. You could path into it from the bottom left, bottom right, or below. If it's a corner one, there's only one possible cell you can step into it from.
Yeah, you're correct. It's just if you want to go from like the bottom center cell to the top right cell, and you can go a straight line there.
Ah,
So it's that there are going to be scenarios where you go to a connecting node, and instead of traveling in that diagonal pattern, you'll either have to like step over one node and then continue that diagonal pattern, which is okay if you're fine with that. But if you want to keep it in one straight contiguous line as much as possible, uh, you would probably have to have the cells uh, basically go through the middle of the connecting nodes. And
I, I feel like the
but
absolute simplest solution in this scenario is just um, only walking directly from side to side or corner to corner, because then you're still on grid, or just use Dijkstra's.
Yep, that looks good. That works for me. I like to go through every single possible scenario and try to figure out the best thing. So I apologize if I did that and I confused you a bit here. I apologize.
No, I just
Um,
figured I don't know if the whole collision line thing is worth like the messiness of it. I,
it's
I
not really that too messy, but I do see what you're saying though.
extra work, maybe the extra work of it. I kind of would be okay with them going quote unquote off grid and pathing from like the bottom middle to the top right corner or something. If we like, I'd be kind of okay with it, but for the sake of consistent behavior, then the option I just presented is most consistent behavior, right?
Yeah, I agree. That works. All right, so I think we have a viable solution here. Um, why don't I have you kind of go over what you think you need to
Well,
do?
the part that I'm still unclear on then
Okay, understood.
is how the sort of like how the world map is chunked into the cell map, if you will.
Hmm. Okay. Yeah, that's. Well, just like you. Shit. Yeah, I'm trying to figure out the best way to just. What is? There's multiple ways this can be done. I'm just trying to figure out the best way to figure out. Um, because once you have the grid, or once you have the shortest path with that, and you travel to the node. Because one thing you're going to have to do is detect which one of the nodes you want to go to, based upon that shortest path, and the Dexter's algorithm shortest path of the cells. And once you have the next cell in mind, you need to reference the map of the connecting nodes, and then just have the character walk toward that node, that connection node. And from there, that node should tell the next node to go to. So if it's moving north or whatever, it would tell it to exit the connection node of the cell it's in and connect to the southern node of the cell to the north. So if this is a inclusive setup, inclusive meaning that the cells or the nodes are inside the border of the cell, like you
Okay.
were describing.
Yeah.
And then from there, you would need to determine in the ordering of Dexter's algorithm what next connection point you need to go to. And you would have that because of the Dexter's algorithm, and you would look into the listing of the connection nodes, figure out which node connects to that next cell, and then do your appropriate functions to find out the best way to get there.
Right. Are you saying
So,
we know which node we're going to because of which cell we just came from?
well, you know which node you're going to because of the greater Dijkstra's algorithm you do for the one cell to figure out which is the best path in cells to get there, if that
Oh,
makes sense.
right. The
So,
path is already laid out. I see.
right. Just the hiccup I had earlier was figuring out if we want to do that one connection cell to another connection cell, or do we want to have a single connection cell for the cells? But no, just do the whatever the north
Well, I like
Middle
the
cell.
multiple connection. Are we talking nodes? Sorry, connection nodes, because that helps us deal with the eventuality. And you were saying it's just going to be much slower. So, seeing as the goal here is to optimize for performance, maybe we do want to do that. It's just it can be blocked quite easily if there's only one of them.
Okay, yeah, that's the okay, yeah, that's the problem. So if you have a block there, um, you can add an algorithm to either look to the right or look to the left, assuming this is a northern southern node connection. We'll just use that as an example. You can just have it looked right or to the left and see if there is a a blockage there, and that becomes the new connection node for now. And the problem is then is what about the other side? What if the other side of the cell or the cell adjacent to it has a block there as well? So those are contingencies that we need to account for.
And if we use the
And
other method, there's no guarantee that the entire side isn't blocked anyway.
correct. Well, either method, it isn't. There's no guarantee the entire side isn't blocked.
Yeah.
So that is there's multiple ways that can be done. The problem is the frequency at which you want to do it. Um, you can make it where that side is just blocked completely. You can make it where they have to go all the way around it. You could make it where you move the cell over until there's a free spot. But what about the other side of the or the other cell that's adjacent to it? So yeah, that's the edge case that you have to account for, which does actually increase processing time, but it is a overall dramatic decrease because of you're only processing information inside of a cell. The question is how do you want to handle that? Handle those edge cases. Do you want to have it where you're whenever a cell is updated, checking to see if those nodes have been impacted, and if they have been impacted, then you act? Which should probably be honestly the best one. And that's not very processor heavy at all. The question is how do you act?
Okay.
Or what do you do with that connection node? Do you just
I'm
I don't know.
assuming we want to look for the shortest route around. So this is blocked, so I'm going to look to the right of it. That's blocked. Maybe I look to the left, and then two to the right, two to the left, and so on. If we if the entire we discover that the entire side is blocked, then move over a full cell or something.
Yeah, at that point, you'd have to do Dijkstra's algorithm again because you now have a block in your current path, and you would have to disable the ability to look up through that direction.
Yeah,
That's difficult.
I see. So, is it not possible to check for these blocks when first doing the Dijkstra's algorithm on the major grid, the cells?
Yes, that was one of the that was a point actually I meant to kind of talk about at this point that you just reminded me of. So there is a how do I say this? This is going to get processor heavy, maybe. Let me think about this. The question is kind of like when would you want to do that kind of check? Do you want to do it dynamically every single time a character checks that cell, or do you want to do it like once every update, which would obviously be the best one? Whenever anything is added or subtracted from a cell, you reevaluate the cell and make the adjustments from there. Um,
That definitely makes the
so,
most sense, but the issue that I'm having with it is like we're disregarding a large chunk of the map just because a single node is blocked.
well, that's assuming like an entire. Well, I had to make sure we're speaking on the same language here. Like the entire side of one of these cells is blocked. You would have to go around it. But if there is an opening gap, you do want them to be able to walk through that gap, correct?
Yeah, sorry, yeah.
Okay. Okay. So, um, perhaps I can think of a few ways. At that point, it could be like if a site is blocked, so side 4 or the processing possibility 4, where the first one was just the straight line between the cells, the collision line, and then Doctor's algorithms in the cell. But if the entire site is blocked, you could do a Dijkstra's algorithm for, just find the shortest path doing a standard Dijkstra's algorithm for that one character. The problem is that you're going to continuously run into that problem, actually, so that won't work. Because if one character has it, they all will. Um, oh, okay, this will work. So if you have determined on a cell update, whenever you do an update to a cell, and you determine that like the north side is completely cut off because of tree line or the edge of the map, or not edge of the map, but the tree line. Um, uh, you essentially would then cut off the top 3 nodes, because assuming the line is all the way across, there's no way to go from uh, one any other connection node to any of the top 3. So what you could do is set for the cell, uh, a boolean, if you will, inside of the node and make that forbidden. So whenever you are trying to do a connection using Dijkstra's algorithm, it will completely ignore those because they are forbidden. And then you would just, if you did cut something down and one became available at that point, you could, make it non-forbidden. But that's only for the connection nodes. Yeah, I think hmm, that's this. I'm thinking out loud as I go over this, so I will repeat myself if I determine that this works. So as you're going from one cell to the next using Dijkstra's algorithm, you can check to see if it will check to see if the next cell is forbidden or not. The difference here is uh, the neighbors. Can't. goes from connection. I think this might be a problem we tackle later.
Could be. I'm just
So
go on.
you're thinking ahead. It's fine. There is a way we can do it, but it's one of those things where you may want to wait until you have the basic pathing and everything working, and then you begin to work on the edge cases.
Yeah.
This is one of those things where we're trying to put the cart before the horse
Right.
situation. I just realized. So, I would say if this solution thus far is viable for you, go ahead and try to get it to work. And because there are multiple ways we can do this, it's just
My final comment on that
figuring.
is that
Yeah,
we're optimizing
we don't.
for performance, right? So
Yeah,
maybe we should go for like the absolute simplest thing, which is just like disregard that cell if the entrance node is blocked off, and we just do a full cell path around it. I guess the problem with that, actually, God, I'm seeing more and more problems. There's very limited options there, and the next cell that we look at could be blocked as well. Potentially, they could all be blocked. We're
yes,
narrowing it down so much that it could be impossible to navigate through the map, even though there's massive amounts of open space.
yes, that's yeah, something I'm beginning to realize. But that it is a bit of an edge, not really an edge case. It is a possibility. It's a significant possibility, one we need to account for. Um,
It leads me to believe that we should have more than just the 8 connecting nodes.
yeah.
But it's gonna be slow, but I think it might be necessary.
Oh, okay. Again, like the whole stepping function, like we had. We have an 8 stepping. We use the 8. And if in the direction that we want to go, that stuff that is blocked, then we switch down to all the connection nodes. So it's just like a stepping process to continuously increase the complexity.
Mm.
Because if we don't need to use the complexity, then we just move on. But if it comes down to a point where one of those 8 connection nodes is blocked, at that point we use Dijkstra's algorithm from that the node the character is in entering the cell to the next connection node. And the problem is now is if that one is blocked, then we can then check the next connection node and see what the shortest path is and go from there. But then that does create the problem that you could get to a spot and then all of a sudden it starts going backwards all the way around another side of the map where it should have just detected that to begin with.
I think
It might be a good. Go ahead.
part
Go
of
ahead, go
why
ahead.
part of why I like to think it through till I have like a clear plan
Mm-hmm.
is because I don't want to set off down some dead end, where it can't.
No, you're absolutely correct on that. It was just there's variations that we can do even later with this. That's the one thing I like about these kind of algorithms, that these dynamic algorithms, you can make changes.
Yeah.
However, it may be more tech debt than it's worth. For this specific thing, considering how complex and all the different variables there are involved with it, I absolutely agree. You are correct on that.
It's getting pretty extreme.
Yeah. The problem is the way that you have everything going, we have to figure this out, this pathing out, because or it will completely just end your game. And
Yeah. Well, perhaps the simple solution is to ensure that the connecting nodes are never blocked in the first place.
that was something I was thinking about, but I didn't want to, limit your. Yeah, but you could do something. I mean, is there something within the game's lore or something like that that you could say? Or you could add
This
something
doesn't
to
need
the
to be
lore?
in the lore, it just needs to be in the spawn system.
Well, but what if a character, like the player, moves a tree to that specific location?
Oh, you're right.
Is what I'm saying.
Yeah, no, you're right.
So if you could have like something within but I'm basically trying to make sure it makes sense gameplay wise if you have that set up
No,
that
it,
way.
it doesn't.
I mean, yeah. So
You could justify it somehow with these like magical portals between, but it's like, why on earth could you only pass from one piece of land to another via this one very specific location? It's insane.
I'm just trying. I mean, you can the generation you could do it that way, but once it's there.
Yep. Many of the trees on the map you'll never be able to move because your sphere of influence never expands far enough to reach them, but it doesn't cover all of our bases.
Yeah. Thinking what's the best way to. It might just be if a connection node is blocked, you just do a full Dijkstra's algorithm and just let it figure it out.
A full, as in like full map.
Yeah. Well, not possibly.
Hey, that's
But
not a bad fallback because it's gonna be extremely rare.
is there something that we can do uh, to even minimize it thin? Basically, once the player or the character gets to that node and then it realizes that connection node is bad, at that point, just do a Dijkstra's algorithm.
Yeah.
And for the from its location, so that way it's not like at the core location. But yeah, I think that would probably be best. That's the problem is what if all of a sudden every character on the map wants to go through there at the same time, which again is rare, but it is still a possibility to think about.
Right. It will never be
However,
every character. I mean, I could see a scenario. Well, okay, the worst case is when you perform a mass exodus and the entire camp travels through the portal to the next level. That is when they're all going to exactly the same place. But the animals won't be, so it still wouldn't be every character.
okay. Scaling complexity is what this is called. Sorry, I just remember the term.
What's it called, sorry?
Scaling complexity.
Scaling
Meaning that,
complexity.
yeah, you check the fastest and easiest first, and then you just scale up in the complexity of your checks until you find a solution. In the thing, which is what this is. I just couldn't remember the term of it for this entire time. Scaling complexity. It just popped into my head. So I think, yeah, that would be the best solution. And even then, when it gets to that point where they're all going through the portal to the next area, if that happens, destroy the tree, destroy the obstacle. The object that it gets destroyed in the way.
Just destroy it. Okay.
Yeah, well, you're God, so you just, all right, this is in the way, boom. It's not going to be any use anymore on the map, so. And it'll be something that'll rarely happen. It'll be a quote rare occurrence, and it'd just be something funny for that would actually be a point where if other people were talking about the game, like, hey, this happened once, and it creates a conversation about the game, which means it's a lot more likely to spread. Sorry, that's one of the.
I could certainly see that.
Yeah, it's just one of those social engineering things. I'm kind of doing that a few times in my game.
Yeah.
But yeah, at that point, I would just destroy it. So
I'd personally, I'd really like to try to avoid that. That's my personal preference. But I was thinking, we have 3 connections per side, technically, right? So it's very unlikely that we won't be able to go through all 3. So I think we're pretty good.
Oh, in that traveling to the next level scenario?
Just in the sense that it's going to be extremely rare that all 3 connections are ever blocked. And if they are, then we just run the full map Dijkstra's algorithm, and it'll be maybe not, but maybe one tiny lag spike in, hundreds if not thousands of hours of gameplay that's perfectly smooth.
Yep, I agree. It's the edge case. Yep, I agree. I like the solution. I like that how do I say reasoning. So
cool.
Yeah, that works. And this may connect, or doing all the other stuff first may actually fix the performance to a point where it won't have any kind of effect when you have 1 or 2 that are doing Dijkstra's algorithm, because they're also not going to make it do Dijkstra's algorithm every single frame or pathing every single frame. Right. Only if there's something that's updating inside of that frame. So yeah, I suspect that it won't be a problem regardless.
Yeah, outside of the portal, the most pathing that they would be doing together to the same location or roughly the same location would be like the hunting parties, which I suppose you can actually make them any size you want. So, but it would be unlikely that a player would convert the entire tribe into hunters, though you could.
I wouldn't ever say that, because there is always one
exactly
that will do it.
Exactly.
But then again, that's an edge case. Do you need to account for every single edge case? So
right, we've done our best to minimize it. But so looping back around to my original question is, I still don't understand how we're chunking the world map into the cells.
Okay, well, start with creating all the nodes first. All the nodes, and like the world node, and so you have all those laid out and ready to go. At that point, you'll need to do a second loop where you basically create the cells and then connect or add the connection nodes to the cells. I would go through and I'll talk about this broadly, and then I'll dive down into it slightly. So you connect all the nodes. First is create and connect the core nodes, or all the nodes on the map, but irrespective of the cells right now, because those all need to be connected to each other first. So create and connect nodes. The second time, like the second pass, is whenever you load the map. Is this will be predefined, because are the maps going to be the same size all the time?
Yep.
Or is it going to be different? Okay, so that this will make this significantly easier then. So, basically, you want to use an offset. And kind of similar to what I've sent you before. Let me go to it. Where if you scroll up to the that create talent major grid chords that I gave to you, and you have that like major grid dot box offset that I have
Yep.
there.
I remember that.
So
I'm seeing it.
Okay. So you want to do something similar to that because you're going to be doing a similar for loop, not a dual for loop, but a similar. Actually, will it be a dual for loop? Let me think. Yes, you will need a dual for loop. And first, let's envision what the cell is going to look like before I start talking about the offset. So you have the cell and how many nodes are in the cell lengthwise and how many nodes are like width and height. What are the number of cells or nodes? Excuse me.
32,
How many nodes in
I
the cell?
believe. It's 32 by 32 nodes.
32 by 32 nodes. Okay.
1024
So,
nodes per cell.
okay. And so we have the top left node, which if we're going to using the GML paradigm of the X and Y, will be 0, 0 of that cell.
Yeah.
Then you have the 31, or sorry, it'd be 0, 31. Yeah, for the right-hand side. The lower, so the upper right-hand side would be 0, 31. The lower left-hand side will be 31, 0, and the lower right-hand will be 31, 31 because of the indexing. And so the center cell, which I'm realizing now it's an even number, so you're going to have a cell that's actually not in the dead center, which isn't a big deal. It's just something to keep in mind.
Yeah.
16. We'll say 15. So it'll be the top middle is 0, 15. The right is 15, 31. The bottom is 31, 15. And the left is 15, 0. Just, yeah, whatever. Is that right? Yes. Okay. Anyways, we'll just go with that. So you have these are your offsets here. So when you create the connection nodes, you basically just need to like loop through where I in kind of looking at my major chords here, first I is X and J is Y. So as you create the greater cells, of course, you'll start with the greater cells of 0, 0, and then go over to 0 or 0, 1, so on and so forth. Actually, so I think that one might make I, Y, and J is X. The inner is the X. Yeah, sorry, I'm confusing myself here. I'm trying to. I have it in my head how I do it. I'm just trying to describe it to you. That's the problem I have. Because typically, if I was teaching, I'd already have something created and just show the code and kind of talk through it.
Right.
But it's very similar to what you're seeing there. Essentially, okay, so we have the offsets. You understand what that is. You're going to have 8 lines of code that's going to create every single one of these based off these offsets. And how I have it in here with the return I, J equals, and then you have like the X and Y coordinates there, you'll have 8 of those. And each one will have the one of those possibilities of the offsets. Because what you're doing is you're taking the whatever the top left-hand node is within that greater cell, and then applying the offsets and adding it to the list of the connection nodes inside of that cell.
Mm.
Did that make sense?
Yeah.
Okay. So, but now the question is how do you determine what is the top left-hand cell, right?
As we loop
Because
through the
you're
cells,
basing,
you mean?
yes. Well, as you're doing your pass to create this to create the cells.
To create the nodes within the cell.
Okay, I think we're looking from 2 different perspectives here.
Uh,
What I kind of, well, there's 2 ways we can do this, because we're not using it. You're not going to use a 2D array, so you don't have to. You're not forced to create everything and put it into the array, because we're using this dual linked list style of node connection. You can actually just artificially create the list after it's like it's like having the nodes out and then you take your pencil and just kind of draw the box around it. It's kind of what we're doing right here.
Okay.
That would be ideal for you, because that way it's significantly simpler coding, because you're going to have all the nodes and then you can kind of just rubber stamp the cells on top of those nodes.
So we're not creating nodes here, we're just defining which ones are the connecting nodes.
Correct, within the cell constructor.
Okay.
So that way you have, this is doing that dual referencing thing I talked about before. So we're going to have the cell connecting nodes that are also going to be just regular nodes. It's just that the cell, a list of the connection nodes is going to be pointing to those nodes. Does that make sense?
Sorry, I think your mic cut out for a second. A list of the connecting nodes is going to be. Sorry. What?
You're good. I don't know what the hell happened there.
Could be the internet. It's been a bit weird.
Yeah. It could be either one of ours, considering our, whatever. Let me get rid of a distraction off my screen. Okay. So you're essentially just creating a reference inside of the data structure for the cell.
Yeah.
To the connection nodes.
Yep. I got you.
And so that is all we're doing here.
Yeah.
And so.
And how does it know which one is in which position? In the order that they exist in that list or something?
Well, it has to do with the X and Y coordinates. Because remember that ID I gave you, that was 3 numbers, X 4 numbers.
Oh yeah.
So, so we're basically going to have to do the calculation based upon that.
Okay.
So the top. So we're going to have to kind of look at it as an ID within an ID, meaning that you have the cell grid, which would be like 00x00. Sorry, the cell ID, which is that 2 numbers by 2 numbers, and then we also have the grid ID, which is 3 numbers by 4 numbers. So 0, 0, x 0, 0 for the top left-hand cell. The top left-hand node of that cell is also 0, 0, 0 by 0, 0, 0. So the cell of 0, 1 by 0, 0, so the next cell over in the row, or in that, yeah, within that row. So you're looking on the x coordinate of the cell directly adjacent to the right. That cell, or that the first node in its top left would be 0, 6, 4 by 0, 0, 0, 0. Do you see what I'm doing there?
No, I'll
And
be honest
then
with you. I
in
was
cell.
getting confused about the freaking grid again.
Okay. Let me see if I can. You know what? Here. I'm gonna pull that PowerPoint. I'll share my screen here momentarily. This is going to flashbang you a bit, but let's see. Share my screen. PowerPoint participant one. Go live. All right. Do you see the PowerPoint?
Yep.
Okay. So give me one moment here to kind of create a pseudo grid. Which there it is. Nope. Is it Shift? Is it Alt? Nope. It's just not going to work. So this is not going to look great, but it's not fucking there. Sorry, I'm having my conniptions here. This will work. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's group. This isn't going to look perfect, but you'll hopefully get the idea. And I can send this to you, or I'll give this to you once I'm done. Kind of help you out a bit too. Kind of. Do you have PowerPoint?
No, but I think I can get it through Google Docs or something.
Okay. I can also just give you an image of it too.
Yeah.
So, all right. So I'm gonna kind of see. Do one more thing here. Probably should have done this in the beginning. Okay, so on the left here, we're going to have, this is a nodes in cell. And it's just a 10 by 10, so you can make the adjustments for the appropriate size later. And these are the cell in room. So these are the greater cells, and these are the nodes inside each one of these greater cells. That makes sense.
Okay.
So what I am saying here is we have a 0, 0, x 0, 0 for this cell. And then we move this over to here, and we have a 0, 1 this, and then a 0, 2 this.
So it's an ID in a map, but also doubles as the coordinates.
Correct. And the let me flesh this out completely here. It may take me another moment or two, but it will dramatically increase, I think, your understanding. Because I have kind of figured out your learning style, I think. So we'll test that theory here.
Well,
and then here,
don't think even I figured that out yet.
I've taught so many students, dude. It's just not to put myself on a pedestal here, but so we'll case this as 0, 0, 0, 500. It's this top left one, and I don't know why it did that.
Also, I think
Paste.
you're using a massive number there when there's actually not that many nodes in there, is there? It's like
Yeah, well, I'm
32 by
trying to marry
32.
it. I'm trying to marry it as closely to what we're doing here to kind of give you a better understanding.
Yeah, I'm pretty
Is
sure
that
it's 32 by 32 nodes in a cell. So it would only be
you're
two-digit
correct?
numbers.
However, these are all the nodes.
Oh, okay.
So
Yes.
I see your confusion there. So
The whole frickin' map.
yeah. So I'm just breaking it down to the corners here, to kind of give an idea. So in 00 here, we have, okay, this, this node is here, this node is here. Let me go ahead and do the other rest of them here too. Just trust me, I mean, it's going to be significantly easier on you. Actually, this would be 63. 63. 63. 63. Because again, 0 indexed. That's 1563. This one is 6315. That's backwards. This one is 150. Wait. 015. This one is 0. Oh. Okay. 00, 15, 0, 63. Wait, it's I'm completely using the wrong numbers. My God, I'm sorry. It should be 31. 31. I doubled it in size in my head for some reason. I apologize if I confused you there.
No, I was kind of adjusting for it. It's fine.
So I was like, this didn't seem right to me because why would it be 15 halfway? And anyways, okay, so 31, 31. So okay, so essentially we have 0, 0. So this is 0, 0, 31, 31, blah 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 blah. So when you go through your for loop, you have your. I'm just trying to make sure I get this correctly. Go back, scroll back up. You have the inner loop and the outer loop. You want to move over using the inner loop, assuming you want to go by x coordinates first, because I actually do the inverse. So I'm trying to make sure I don't confuse you by doing the
Yeah,
inverse.
I usually go x coordinate first.
Okay, because I'm going row down and over. You're going over and down.
It's been so long since I've done something like this.
Luckily, I have just gone through this, but again, inverse. So I'm having to make the adjustments in my head as I go here. So okay, but
yeah, I usually go x first. Yeah.
So yeah, here I have ji. It would be ij for you.
Okay.
So I will actually just make that adjustment here in the edit.
I did. It does seem more intuitive to go like row by row than column by column, though.
And if you want to do it that way, that's fine.
No, because I like made myself learn it the other way, if you know what I mean. Even though I remember thinking that feels less intuitive.
Yeah. Okay. Yeah. So I guess I went the more intuitive route from your description. So okay, but all right, from here, kind of. So you'll write a line of code for individually for every single one of those. There is a way you can do it again, or like another for loop inside. I highly recommend you just write 8 lines of code to us to add in the those nodes into the connection nodes of the cell. So you would create let's just a DS list actually a map inside. I would recommend a map just for easier access.
Okay.
But keep in mind you have to destroy them. Just make sure you track your memory.
Oh, jeez.
And I'll show you a really simple way you can do it after all of this, because I do something similar and I already figured out a way to do it. Anywho, so you write 8 lines of code and you're basically going to take these numbers, the 0, 0, 0, and the zeros, and the x and the y coordinates, and then multiply them by 31 for this one, and then 31 and 15 for this node, 31 and 31 for this node for x and y respectively. And but how you do it is if you look at my code for the sorry, here it is, for the create talent major grid cores. You see how I have the starter x there plus the multiplied by j and multiplied by I. What this does is that it accounts for the 0 index. So when you're adding in the cell, the nodes to the cell, it will. God, I'm trying to figure out the best way because this is actually slightly different than what I'm doing, but the same principle applies. I'm just trying to figure out the best way to explain it to you. I'm doing it once. You're doing it 8 times. So the difference here, I got a paper of notes that's getting very messy. I do those. It's multiplied by 64, I believe, each time. Or sorry, 32 each time. So you start off with 0, 0 and map this out before I try to explain it to you. Then it goes to 32. Then it goes to 64. 0, 0, 0, 0, 0, 0. 32. 0 first and 64. Uh, 0, 0, 15, 0, 31, 0, then 0, 15, 31, 15, 1. It's funny that your thing is significantly more complicated than mine for my grid, for my talent grid. So hold on, I've got to figure out the pattern. So you create a all right, let me make one adjustment to code I sent you after that that node at the bottom that kind of talks about the coordinates. Node ID Y. Wait, no. Sorry, I am. There's two ways you that you can create these nodes and the cells and do it all. And the way I'm describing it is a simpler way to do it. You can do it using a do it all at once. I'm just trying to see what might be better in the long run.
Mm-hmm.
Because you're gonna have the two maps, but do you think this is like what I'm about to say is what they call a cross reference, and you'll have a node. Each individual node will be inside a cell. You can have the information of that node knowing it is inside the cell, so it is actually storing the value of the cell that it is contained within. And at the same time, you can have a cell that also has the same information. When you do this, it creates that cross reference where you'll be able to reference all the nodes inside of a cell very easily, as well as be able to tell what cell a node is in. So again, it's that cross reference. If you wanted to set that up, you can do it one of two ways. One, do them both at the same time, based on a mathematical formula, or two, just create the world map of nodes, like I've been talking about, and then go through each and every single one of those nodes and figure out where within the cell map they would fit, and that would just be based off of a mathematical calculation. Both of them are correct. Both of them have their advantages and their disadvantages. Although this second way, there's a third way you could actually access it. God, sorry, I am probably confusing you. I apologize. I'm just trying to figure
I'm
out
with
the
you so
best way to
far.
teach this to you. So, yeah, well, quick side note. I'm not prepared to go over this today, so I'm trying to coming up with a lot of it on the fly, trying to figure out the best way to do things. So,
Yeah.
I do apologize for that.
Well, no worries. Appreciate the help. I mean, you've spent a lot of time with me today, so.
Oh, God damn, I didn't even realize that. Well, it looks like I might not be streaming, which is fine. I probably still will. But people who know me know my Discord, so we'll go from there. Anywho, back to what I was away from the distraction. My distraction. Okay, so D. Oh yeah, I was changing this. So what I'm going to suggest. Screw it. I'm going to give you. I'm going to give you the formula. I was trying to think maybe I should make this a learning moment, and I'm thinking to myself, God damn it, you're not in college. So give me a moment here. I'm going to the constructor function. I'm going to basically just give you the the code. So let me actually open up my other, yes, save current project. Share this screen. You can see my GameMaker.
There we go. Yep.
Okay, it just took a sec. Correct. 2. All right, so I am just going to give you this. So I'm actually doing what I don't like to do, but again, this is a it is 15 by 31. And 0, 5, 1, 2, 3. Okay, so dot build ID. Let's first mess with this. Self.node. You know what? I just can copy this directly because it is actual code. That. This is the individual node, and the way we could find the cells is this will actually be done after. Yeah. So here, okay. So here, this is because it has to be every 32. Or y. So basically, until it hits 32, it's going to be 0, 0. It's going to be within that cell. So
Yep.
once the cell core, so yes, so you understand what I'm doing there, right? So you're dynamically creating the cell locate, or the cell IDs for it. So that does that make sense? What I'm doing there with all that?
It's the. I thought it was like finding the top left node of each cell or something.
Okay. I am sorry. I completely diverted over to something else because it was going to become a factor. And I did not explain that, so I apologize for that. Let me finish this up first, and I'll understand. I'll let you know what's going on. Another problem I have is sometimes I don't always realize I didn't say what I meant to say. Okay, so this is the basic node setup. So now going into the cell, here. Okay. Okay, so you'd have this, and then you have self dot. I'm just gonna make this an array, or no, you need to make it does need to be made a map. Nodes equals ds map create like that. So for the first, basically what you are gonna need to create everything separately and then combine them. So let me just take what I've done here. It's fine. That'll work. This will make sense, I promise. I'm just trying to piece it all together here. At least I hope it will make sense. So it is 511, 5024, actually. Because it's less than, so it's exclusive there. Um, I do see one problem. Oh, hold on, let me look something up. Doing this on the fly is string formats. I have not actually had to do this yet. String format. Real number converted to a string. Number of places the main number will be shown on the left side. Okay. So this is actually string format. And the value 4 0. So do you know what string format does? Because
No.
this is the first time I've used it.
Same. Never
Okay,
seen
so
it.
what this is going to do is force 0 0 to appear. At least that's what I am hoping will happen, because I haven't had to do this before. So do check it before this, but the principle still applies. So essentially what is happening is, so if this is 0 or x is, let's say, 00 here, it needs to be 2. This will force when it creates the string from this number, it will force it to be 0 0. And if x is 1, it'll force it to be 0 1. So this way it ensures that we have this here, because if we just directly convert it over, it'll just be 0x0.
Yeah.
And not 0 0. And you specifically need it to be 0 0.
Right.
Theoretically, you could get away with not doing it, but by having it's better to programmatically wise. I could go into why later, but to keep the same, because we're using them as grid coordinates, keep all the characters in there.
Yeah.
You could get away without doing it, but for the sake of argument, my personal opinion, feel free to change. I could do the same thing here. 2 0. 2 0. Silkhorn ID. That actually did change, so do the same thing here. Yeah, that's right. Okay, so we have that. And then we can just pass in the numbers directly, which is what I want to do here. However, we still need to set it up to do this here, because we're adding the DS map. That DS map, this is going to be the key, which is going to map or mirror the information inside of here. And then we have the value of new node, which is INJ. Okay. Does it make sense what I've done here so far? This is actually,
how are you getting this node X chord and node Y chord before you've run new node? Isn't new node the thing that generates it?
no. The I and J here, these are your node coordinates, so X and Y.
Yeah.
So when you pass in the I don't say this, because we're just creating the IDs right now. So like I had described before in the crap, where's my other PowerPoint. I'm so used to that. So okay. Let me be able to switch back and forth easy. Here we go. So we have right now we're making this number here for the individual IDs as we put everything into the map, the world map. So this is I, this is J. So I and j, and when we're creating this new node up here, we're passing in I and j, and so as it goes through, it'll automatically create the chord with the individual node as well as the cell chord location.
But
So we're finding all. Go ahead.
in the beginning of that DS map add, you have node X chord and node Y chord.
Yes. Okay, this is your hangup. This is. Oh, I see what you're saying. I made a mistake here. That should be I, and this should be J. I see what.
Oh,
Yeah.
okay.
Sorry. That's my brain thinking too fast here. But yeah, that's what this is. Sorry, I misunderstood.
Easily done.
Yeah. So there's that. So that will create the node map. Then we have this will be fun figuring out this part though, because I haven't mapped this out in my head yet. So it's 16 by 32. So which essentially, yeah, that's it for that. Well, 2 and 2. So now
And that should be
we'll
new
have
cell, right?
Yes, thank you. I always make stupid mistakes. But good, yeah. This what we're doing right now is what they call pair programming. And for the exact reason that we have already ran into twice for figuring out mistakes in front of each other, because you're not in my head, so you're able to see things I don't.
I'm the observer. Yeah, I mean, yeah, it's you're just trying to go fast. That's why you miss. Like I do it if I'm rushing. I miss stuff all like this exactly the same all the time.
Okay, so yeah, this would be separate file or something. I'm just to separate that these two are the constructors. So okay, we have these two combined. Now, I'm actually going to, let's see, make an internal function.
So each cell is a struct in a map that contains an X coordinate, a Y coordinate, and an ID.
Yes. I don't need to use this proper programming, but for the sake of the argument, just keep things simpler. So now we got to create this. We need to add nodes to cells. And then what's the I don't remember the function. There it is. Hold on. Get these. DS, there it is. These to array. I keep as long as I've been programming in GML, I still forget that it does functions versus other things. So this would be ID of dot. nodes keys. What? Return value of pure function is not being used. Returns array. Oh, I'm an idiot. Misunderstood what the documentation says because it's not clear. There we go. So what this, okay, what that will do is take all of the keys out of the map and put them into an array. So now, here's the fun part. Done this a few times already, but so this is shorthand for pulling the variable out of the map.
What? How does that work?
So there's actually a DS, what is it? Map find value. It replaces this. So what do they call these things? I can't remember.
What?
Basically, it's a character that's. Go ahead.
The question mark is just a short version of that function. But why
Correct.
does it say key there when you're doing key equals? What?
Oops.
No, oh, okay, that makes more sense.
I'm sorry.
Okay.
Again, going too quick here.
Yeah.
Okay, let me slow down. I'm trying not to take too much of your time, but I'm realizing it's actually costing more. So we're going to be looking through every single one of these. So we pull out, actually it's not key, it's node. So we're pulling out that node.
But node is a function.
There. Well, for the sake of, well, okay, so now we need to, that was the best way to do this.
Okay.
Node dot. Okay, I do actually need a function here. I'll explain.
Oh yeah, that's what we're doing. I'd forgotten why we were even doing this. We're assigning them to a cell.
Yeah, and then doing the inverse as well. So
Okay.
here, attach to cell. So I mean, when you actually do this, take away the global and actually pass in this information, but just for the sake of brevity, and so you can figure out how you want to pass the information around. Because, yeah, again, I'm just trying to get this out to you so you have something to work with, so you have an understanding and, can move forward here. So this is attach to cell, global cells.
What is the question mark again?
Finding the value of, basically it's using the key to get out the value of the map.
Using the key to get the
And
value.
so actually, this isn't what I'm looking for here. This is add. Okay, this, okay. Did that wrong. But this is cell ID and self. So what I've done here is because it's self because it's within the constructor. So it will add. Give me a moment here. I apologize.
The key is the ID,
okay.
right?
I did pulling out the cell. Oh, I see what I did. Dot nodes. It is this with cell ID. Yes, that's correct. So it's taken the root cells function using the cell ID that we created, that we found at the very beginning. It's finding the nodes, which is down here, and adding the key of the, oh, it's the node ID, and then adding itself to it. So this is literally just adding itself to the appropriate cells node. Does that make sense there?
No. Global cells is a DS map.
Yes, which is the world cells. This is the world's nodes. So think of global.cells as the world that we're trying to create here.
Okay, and then the question mark is we're retrieving what's in the cell ID.
Or that specific cell. Yes. Within the world cells.
Oh, so cell ID there is the key that is making us look at a specific
correct.
Oh my god, it's
Specific
still
cell.
confusing. It's still
Correct.
confusing. Global cells is a map full of cells though. How do we know which one we're looking at? Is it all of them? No.
It's pulling out the cell ID which we created.
Oh, it's okay. It's
up here.
Right. Okay. It's looking in the map of cells for this particular ID, which is a struct that contains node. So we're accessing that, and then we're adding the node ID to it. That's confusing. Where are we getting the node ID?
Right here.
But which node is that for?
Exactly. So we've already created the base nodes here and the base cells here. So now we're going through all of the nodes, and I haven't attached the function yet.
So we're going to pass it into the function.
Well, we don't need to pass it into the function.
We don't need to.
We just need to do this. Because this is a function that is a part of this constructor, meaning that all you have to do is do attach to cell, and it will automatically use all the variables that is within this instance of a node, and then it will attach itself to the cells.
Okay.
To the appropriate cell.
Okay.
So now.
Why is there self at the end? That's the last question.
Because it's attaching itself. It's this node that we are currently working with going into the cells. Because of the way constructors work, this is one of the core facets of object-oriented design or programming, is that it's essentially the same as using with, if you want to think of it that way.
No idea what that is.
So if you have a struct, let's say, how do I do this? How can I show you this really quickly? Our temp equals A1, B2, Then we have with.
Oh, with. I thought you said something else.
Okay, so yeah, you know what with is.
Yeah.
And how that works. Then you can make A equals 4 or 3 now, and it recognizes you're talking about this.
Yep.
Okay, so you got that.
Yep.
So you know that. It's essentially the same thing as a with.
Okay.
It's with this node, use this function that's attached to the constructor.
Yeah.
So then it adds itself because it's with this node that we're looping through.
Yes, the node we're currently running this function on is being added to the cell.
Correct. So, yeah. I know it's convoluted for, I mean, I guess something that
I'm just
for so
totally not
long.
used to it. It's crazy. Like, you know, I've been programming for 3 years, and this stuff's basic, and I'm only just, you know, you're blowing my mind. It's crazy.
Well, this is one of the reasons why I was like, you know what, screw it. I am going to do what I hate doing the most is typing it out. But it makes the most sense for this current paradigm.
Yeah, you would have never have been able to explain this to me without typing it out. I would have never got it.
And that's the reason why I was like, I got it. I have to do it and just show it. Okay, so the next part is, I don't think we actually, let's comment it out for now. For the cell, the nodes. Then at that point, so we attach to cell, and then we attach the node to the cell. So that's in there. So now we need to, in one sec here, what's the inverse? Oh, I think we've already done the inverse because the node knows which cell it's attached to, but the cell now knows or is now added. Okay, yeah, so that would work. So now we have basically married the node into the cells. And because the node already knew what cell it belonged to, but now the cell knows it belongs to it. So the next part is the add neighbor, which I am just going to have you reference that. Expand my window here. So if you look in what I sent you before, there's this. It's going to error out because I don't have any of these functions. Actually, no, it shouldn't. Yeah, that'll work just fine. So now in the node, we need that. And weights. Wait, that's under a DS list, yeah.
And you were saying earlier the order of them is important, so a list is the right choice.
It will be, yes, because the ordering will determine how each cell sees the next one, in what order it sees them.
Yeah.
So, but basically what that means is it is more likely, assuming you do like starting from like top, middle, and going on a clockwise pattern, it'll be more likely to go up and right before down and left.
More likely?
Or it's more likely. I said that wrong.
Guaranteed to.
Basically, if you're going to go diagonal, like up and right diagonal, it will first go up and then go right. if you're trying to go down and right diagonal, it'll first go right and then go down.
Okay.
Because it depends on which the order at which you add them in there.
Yeah.
So now we have this add neighbor. The question is, what's the best way to actually add the neighbors?
It's a good question.
Because this one's going to be a little more convoluted. But this way you have so far. Let me do this. You will actually need to add in this. You will need to pass in the X and Y coordinates. How many pixels wide are these?
The nodes, 32.
Yes. 32 by 32 pixels?
32 by 16.
So 32 wide or 16 wide?
32 wide.
Okay. Oops. 32. 16. So or 0, 0 plus. Do you want the chords to be from the center or from the top left-hand corner?
I've always worked with the top left-hand corner and then added an offset. But
cool. So
I
that's
mean,
fine.
if we just don't want to add an offset, we could go center now. We are converting everything over.
So at that point, then it would be 32 wide, so plus 16 plus 8. I'll explain this in 1 sec. You might want to change it to like something like this.
Yeah.
Yeah, because that's what I do personally. Typically. There's a couple times I haven't. All right, so now you have the XY coordinates for all these individual nodes in there now. Because it's starting with 0, 0, then it's multiplied, then it moves over for every I, and then down for, or multiplied 16. So I think you see what's happening here, right?
Yep.
Then we're putting it to the center of the square. So okay, so you have the XY coordinates. So that's one thing I meant to do before. So that's in there for you. Now adding the neighbors. The best way to do this.
Would the first cell that we look at be based on the direction between this node and our destination node?
You can do that. How do I say this? That's going to take, would be ideal. However, the pathing and the connections will take care of that for you for the most part. It's just that understand that the characters are going to move in a direction or move in their respective, how do I say this? They are going to move in a priority direction. It's not going to impact much of anything in the end. It's just that if there is whatever the shortest path is, if it's direct, like up and to the right, it's going to go up and right first. If it's down to the left, it's going to go right, then down. Then if it's going, to the lower left, it'll go down, then left. If it's going to the upper left, it'll go left, then up.
As in the order that it checks the neighbors?
Correct.
Yeah.
So it's okay. Yeah, it's honestly not a big deal unless there is a specific reason why you would need them to path in a different way. I wouldn't worry about it. And if you do need to do that, I say come back to it later.
What is dictating that right now? What tells it to... You're saying it's the cardinal directions. Is that right? It's 4 directions, not 8. Or is it?
Oh, well, the thing about it is, though, if you're wanting to check, okay, it's because each square, assuming not an edge square, it has 8 directions that it can check.
Yeah.
Because if you're wanting the character to move a diagonal, you need to have that as one of the weights or one of the vectors out of the cell. Yep. So that is the fuck. I did it again. You're right. Disregard. It will just look at the yeah, it doesn't matter. It really doesn't matter, does it? No, it does not.
But I'm
sorry. I am yeah.
What's happened?
Disregard what I was saying about the priority. It's insignificant. It does happen, but it's insignificant. It's just
so we would scan them the same way every time.
Yes, it'll scan them the same way every time. It does it in the end. It'll be irrespective to the user, irrespective to you. Yep. It's just I went back to my framing of the 4 cardinal directions instead of the 8 for some reason. I was thinking in the 8 cardinal directions, but for whatever reason that shifted. I don't know what happened. I'm gonna chalk it up to my brain damage. I honestly don't know what happened there.
I was just wondering, like you were saying that it would. The first Jesus Christ, the first cell that it checks would be different sometimes. Like you were saying, it might check right first or up first. Based on what, though, I'm wondering.
Oh, I'm sorry. I was unclear with that. Depending on what we add first.
Oh, the order.
Well, the order. So, and because we are doing this all dynamically, because I don't think you want to go through and do thousands of if-then statements or switches.
Not really.
Like, do you want to check up first? Do you want to check right first?
Oh,
because it really doesn't matter.
So you were posing it more as a question.
Yeah,
I didn't get you.
That's it.
So my default go-to, because it's like the GameMaker way, is to check right first and then go counterclockwise.
Okay, so if that's the case then. We already have keys, so we don't need to do that again. Actually, we can do it. We don't need to do another 4-state, or we can do it in here. But
oh, so we do it at the same time we add them. We also generate the neighbors, connect the neighbors.
Well, yes, you can do it in other places. Just since we're already messing with this node, we can go from there.
Absolutely.
So I'm going to generate the first one for you, and then I'll let you generate the other 7. On how to connect them.
Okay.
Well, there's 8 of them, but I'm going to do the first connection for you, and then I'll let you. It's essentially copying and pasting, but you have to change some of the values in there.
You were saying this is the
but
thing that could be done with an additional for loop or two.
yes,
Uh,
but we can also do it
we
in
can
just an
write it
8.
out.
We can correct.
I might, if I'm feeling confident, try and do the for loop method.
Actually, no, you can't.
You can't?
Not with a for. No, because of the way that the IDs are set up. So
Fair enough.
thinking like the top left node, we're gonna add neighbor to the right. So
Oh, it would be very weird how you have to like modify the Y position and then the X position a couple of times and then the Y.
exactly.
Yeah.
So we have global nodes. Then we got to get the ID. So you got node ID. Then node dot was underscore X. So we got the first node for the ID, and now we're grabbing the X coordinate of this node, and that's actually the wrong one. Sorry, it's cell X coordinate. Sorry, confused you there. Confused myself there. That and that.
Okay.
So we're pulling this, and then since we're just going to the right, we just increase it by 1.
Yeah. I can do the rest. I've done it many times.
However, because you don't want to add a cell that doesn't exist, right?
Probably not.
So yeah, you'll need to check that for all 4 sides and in the direction you do it.
Array length. Wait, how could we be? If it's just based off the array length, how could we be adding something that doesn't exist?
When you get to the far right-hand side of the map, this will still do a +1.
Oh, like off the edge of the room.
Correct.
Gotcha.
So this way you have that. But yeah, so you do that for the other 7 in just the appropriate directions, because then like for real easy for the next one.
What about Y? Can it not look off the bottom and top of the map as well, potentially?
Correct.
So I can't be less than 0 either.
Correct. However, keep in mind, yeah, you're right. So you would, as you go around, you just have to double check all of them. And this one would actually be, this can go bottom right. Actually, I don't think you don't need to check Y here, because if you can't go right, you can't go bottom right. So you don't need to do another.
Okay.
do this. You could actually just do this.
But you could still go down.
Yes, but this is specifically adding bottom right.
Yes, I know.
So you don't. Something I like to do, which I think you've recognized my coding style there.
Yeah, it's
But
nice.
let's see. Right, bottom, right, and
Oh, this takes me back. The first time I implemented pathfinding, there was a lot of this.
J is at max of 1024. So if
Yeah, but there is no J, is there? There's just one for loop. Based on the length of the array.
yep. Okay, I see. Yep, sorry, I'm conflating here. This is shit I do constantly. So instead we need to check if node
Oh, yeah.
cell x forward plus 1 is less than 512. There we go.
Good lord, this is a nightmare.
But once it's done,
It's done.
exactly. 1024. This is actually a little simpler than I thought it was going to be. So this
I think that's
is
supposed to be an uppercase Y, isn't it?
probably. So you got right, bottom right, down, down left.
Why are we going clockwise?
This is just the direction that I. Well, oh, are you wanting to go up left?
Counterclockwise.
Yeah. Okay.
I'll fix
all
it.
right.
Yeah, don't do that now. I can change it.
So, okay.
In fact, I can fill out the rest of this based on the examples, so you don't need to
Well,
keep
in that
going.
case, I'll just. There we go. I'll just let this. So yeah, there's the example. Is just take your stuff there. So that's adding your neighbors. That's everything connected. The only thing that you need to do now is what I was trying to show in the beginning of this. I did
Okay,
all of this to show you this.
awesome. We're bringing it full
So,
circle.
exactly. So it's very similar to what did I do before? The XY, or yeah, this right here. Basically the same thing when we're creating the cells. But this needs to be done after the everything is created. So at this point, I think you need to loop through the cells. Hold on, give me one moment here to think about this. Is there a better way? Attach to cell. I honestly think, just for the sake of both of our sanities, uh, and it's the same thing for this, but cell. Nope, nope. Okay, there's that. And it's another, got to do all 8 of them again, but I will. starting with the right.
Okay, we're just getting all the cell keys and putting them in an array.
For this here, but this is actually attaching the telling the cell what is next to the or the
neighbors of the cell.
correct, which is going to be a little different, but I need to think about this a little bit here because it's not node.
So is there going to be like one central node for each cell used in the Dijkstra's algorithm?
No.
No.
Maybe?
Wait, I thought you said that before.
Sorry.
And it would be at position 1515.
But we could use. Again, there's multiple ways that we can look at this. However, this is going to be...
That would probably give us the most accurate paths, right, if it was kind of looking at the center, roughly. I mean, that one wouldn't even need to be on grid, so it could be right at the center, I'm guessing. Other than the fact that placing it might be more challenging.
Thinking. Okay. The center actually simplifies things. We still need to have at least with the current iteration I'm thinking in my mind, a inner grid in the cell of where we had the the 8 nodes are going around the outside. Plus, if we add the ninth one in there, it will just create this. How do I say? It'll be a better pathing for figuring out where it needs to go.
That's what I figured having a center node would do.
I'm just trying to figure out the best way to marry this in my mind, because there is a slight deviation than just adding the nodes like we have in adding the neighbor nodes next to each other. I'm trying to piece together the best way to describe this.
Mm-hmm.
And by the way, if it's getting late for you and you want to revisit this tomorrow, I'm fine with that. I'm not saying leave or I'm done, but I'm just letting you know. I know it's getting real late for you. So
I'm good for probably 30 minutes. I could push it to an hour maybe, but yeah, I'm starting to run out of steam for sure.
Yeah, I'm sorry. I
No, I mean, it's fine.
I honestly didn't foresee this coming in this way. Um,
At least if we get it sort of like out of the way in one day, you can get back to your stuff and I can take off with it.
True. But I don't mind the break a little bit here to help you out with this at all. So don't feel bad, please. Um,
Glad to hear it.
Problem is with we have the 9. Okay. So here. Okay, so the way I had to say,
Jeez, we haven't even gotten into the weights yet, have we?
I don't worry about the weights. It's just something that we have to do for nut textures. We could theoretically just rip them out, but you want to keep them in there in case you do decide to add weights in later, because adding them later could be not quite as fun.
Yep.
Or making the changes later on could be fun because like this is all going to be one here for the weight, but if you ever decide to change it, it's easier to change this way than other ways.
Right.
Um, Also, if you ever decide to add terrain, and there's different ways to, traveling through them or whatever.
I don't
It's there.
think I will, but nice to have the option.
Exactly. Um, so, sorry, I'm just trying to piece through the thing. So basically, we could do the exact same thing for the cells, and just have the weight, have the neighbors and everything else, and um, so we have the cell, we have all the nodes, we have the no. Before I do anything else, yes, map. Essentially, you just call this at the end, and when you need to destroy them, you can loop through them all and destroy all the maps, so you don't have any memory leaks. Is all I'm doing here.
Yeah.
So, doing this now before either of us forget. You don't come back later. What the hell's going on? And because I've already ran into that with my last problem, with my last iteration of my talent tree, and
Oh, jeez. Yeah, yeah. I've not done anything this extreme where there's like, I mean, it's a hell of a lot of lists.
so yeah, I like to have everything set up to go just in case.
Yeah.
So we have the nodes in there. We have the connection nodes. Um, so the first thing we got to do is add Question is how do we marry one connect node to the next connect node? Not going to be hard. Okay.
Yeah. It's between 1 and 3 neighbors, right? It's 1 or 3. I
Well,
don't think any of them have 2.
I'm thinking that we only allow like the northeast connect node to connect to the southwest connect node of each cell. Just one and one.
Yeah, but what about the corners?
Ooh.
The corners could connect
Here's
up diagonally or right, for example.
corners. Oh, we are trying to find the shortest path that way. This would go to the edge. Sorry, I'm thinking through something else that not related to what you said, kind of. If they are able to go diagonally, you don't need to connect. Oh, I see. Okay, actually, I now that I have something to show. So, assuming we're going from 0, 1 or 0, 0, 0, 1 to 0, 1, 0, 0. So here to here.
Mm-hmm.
If we're going this way, we only need to connect this this corner node here to this corner node here.
Yeah.
Because we don't need to connect this one to this one.
Well, we might.
Because if
It gives us our backups, right? If the...
you're right, correct. I forgot about that. Yep, you're good. I understand what you're saying.
Yeah. 3 doors aside. Well, some of them are shared. It's hard to imagine them as doors.
There is an option to do this.
It's kind of like revolving doors on the corners.
Yeah. Oh, that's a good way of putting it. Sorry, I'm trying to piece through the best way to do this. The thing about it is with these cells, the cells are going to connect to each other like nodes. They're going to, okay, so let's stop what I'm doing here. This is not the right thing. This is not adding the connect nodes. This is add the cell neighbors. And it's doing the same thing as this, but just with cells.
Yeah. Cell neighbors is different from the connecting nodes.
Correct. And that's what I was string cell.
And I was thinking about it before. The cells essentially make up their own grid. So you could center up the middle cell node because in a sense it's in the middle of the cell in the larger grid. Because no creature is ever going to try to path to it, so it doesn't have to be on the smaller grid.
Yeah, you're correct. Hold on, let me think this through because I'm confusing myself here. So attach to cell. This is the neighbors. Add nodes to cells. This Okay, this is what was confusing me. Should be node, not cell.
Uh-huh. Well spotted.
Okay, so here you have cell dot cell ID. That is what we called it, right? Yes. Cool. So then okay, so we have add cells to neighbors, and we still have the keys. Here.
Did we ever make the cell nodes?
Wait, yeah, it's not nodes. This is cells. Cells. This is
There's one more. Right.
cell. Which I didn't add the underscore in front of these.
Oh, yeah. Yeah, we're running a function in there.
Well, yeah. So, okay, so there.
Wait, is that
So, yeah,
global nodes? Is that one supposed to be global cells as well? Next one.
Yes.
Okay.
Pair programming is a wonderful thing. It's annoying as shit when you're trying to work though, and the other guy is constantly saying, "No, you're doing this wrong. No, you're doing it wrong." You're not telling me that. You're correcting. You're pointing out mistypes and leaving crap out. So here we have. Okay, I'm just trying to make sure this is all. Add cell to neighbors. Doing that here. To do the rest, and then still in this. So here we have an option. Here, this is what I'm about to do is not for the Dijkstra's algorithm. It's for pathing specifically. So when you go in and you actually calculate the pathing and pull out the XY coordinates and whatnot and tell the character to move to that location, this is what this is for.
Okay.
This is irrespective. Everything else that we have done is for Dijkstra's algorithm. You're good to go with Dijkstra's algorithm with all this once you have it completed. For the most part, we'll have to. I'm gonna want to come back and look at this tomorrow just to double check because I always come back the next day when something like this to verify that I, fresh eyes, fresh mind.
Yeah. So are you saying this is for when the cell is empty?
No. This is how you're going to determine what the next cell or what the next grid you need to connect to is for pathing specifically. Essentially, because we have like the top, we'll go back to the thing here. So we'll have this node right here thinking like 0, 1, 0, 1 here in this cell, looking at the top right-hand node connecting to 0, 1, 0, 0. So it'd be this cell.
Yeah.
These. So what we're going to do is make it so.
But it could also connect to the other two, just saying.
Yeah, I'm actually conflating two things in my mind. Top right. Because the way we have it set up is that Dexter's algorithm will just connect to this one, connect to this one, the cells. It's not gonna, when we're looking at specifically the cell algorithm to find the shortest path, it's not going to see the connecting nodes. It's
Right.
when we move from one, like moving the character from one to the next, this is what this is for. That this part that I'm going to do.
I see.
So
my basic understanding of it before was that we sort of compile all of the nodes of all of the cells that would be used in the path, and then look for the path through all of those.
You know, now that I have it in code, and well, okay, here's the problem. The way Dexter's algorithm works is that it will look at each cell individually. So there is no way for us to pull out all the node information.
Oh my god.
And exclude the stuff outside the cells, because the nodes are still going to see the neighbors of if they're on the edge of the cells that are not being included.
So we're only pathing through one cell at a time.
Correct.
I see.
So
so
kind of going back to that list.
Are you saying there's like an additional little bit of handling then that's almost like to step into the next cell, because you've reached the end of the path, but we got to get you into that next cell, and that's what this is?
Correct.
Okay.
And trying to think about something here. No, we still need the full world map, so to speak, for the nodes in case we run into a large amount of problems. So I was thinking if we could make a actual change, but
the world
no,
map is our fallback, right?
Correct. So we need to keep it the way we have it here. So
It's got to be very good for performance, because the paths it's generating paths more frequently, but they're much shorter. I imagine that must be a lot faster.
Yes. The actual path between the grids, correct. That's the whole point of why I was like, yeah, you need to do this.
Right.
I'm just trying to think of what's the best way to do this, because if it was connecting one to one, it wouldn't be as hard.
Yes, I figured it would get a bit tricky having the additional connections.
I need to think through this for a moment. I'm thinking, I think it might be logic outside of the creating of the world that we need to implement to look at other nodes. Because to make sure that I'm understanding your perspective on this, what I am thinking, again, is just having this corner node up here connect to this corner node here. That's it. But if either one of these is blocked, how would we handle that?
Well, if we were to do that and either one of them was blocked, then we have to resort to the entire world map. We don't have like
That is correct.
we don't have like a secondary. I was proposing the 2-tier thing, but if it's more complicated to have that middle option, then I suggest we do limit it to one connection and just go straight to the world map in the event that we can't do that. We
Yeah,
can't
like you
find a
said,
path.
it's a fairly rare occasion,
Pretty rare.
and it's only if it is like traversing that node.
Well, it's
And
but all of the having only these 8 connections, all of the paths are channeled through them. So
correct.
It's not that rare if we're not doing the multiple connections where like you have 3 aside, so to speak.
Yeah, but at the same,
But I still think it would be good enough to have the 1-to-1 connections and then just fall back to world map when we need to.
And there's also we can also add the functionality later if we need to. So that I guess the way that I'm building this is that it is going to be possible to make adjustments, and it won't be too drastic.
Mm-hmm.
But it does have the capability to do it, and because it is so dynamic, it allows you to do it. That's one of the reasons why I program the way I do, and why I have all my crazy dynamic stuff, because it's so malleable, and it makes things. The front end sucks building it, but the back end, it's smooth as butter. Is the best way I like to put it.
It's totally worth it. I fully understand.
I'm just trying to figure out the best way that we can do this. Okay, 2 options for you. Well, I'm going to tell you what the option the way that probably needs to be done, and then you can kind of make the decision if you want to use an enum, which I would highly recommend. So essentially, you want to go clockwise. So think of the 3 o'clock position. Counterclock. God damn it! Sorry. Yeah, counterclockwise. You're right. So starting at the 3 o'clock position, let's do an array of 0. And then at the top right, you have 1, the top 2, going all the way around to 8 for the outside.
Mm-hmm.
This will allow you to because it is set. You don't need to use a map for this specifically, because you're just pulling whatever cardinal direction is out of that cell that you're wanting to use, that node specifically. Does that make sense?
Sorry, I got hung up on the fact that you said cardinal, but we're doing 8 directions, are we not?
Sorry, military wise, or at least when I was in, be thinking cardinal northeast is a cardinal direction, because it's a combined cardinal direction. Sorry, it's force of habit. I apologize. Different vernaculars is what's confusing you here. So confusing both of us here.
Run that by me again. Sorry.
Okay, so 0 is the right direction.
Yep.
1 is the top right. The top 1 is 2, and going straight top is 2. It's just an array of going in that counterclockwise order.
Yeah.
For the connect nodes. So this is one less thing you have to worry about in that regard. So it's just an array. There's that. And so add, so I'm just trying to think of the best way to do this. Because we have the top left is 0, 0 in the grid. So fuck. This is gonna have to be outside. Yeah, this is gonna have to be outside. This has to be another dual for loop for these.
It can't be done at the time of originally adding the nodes to the cell.
Actually, yes. You would do it here. And you would, but the problem is that you're gonna every single, well, I mean, again, you're doing, this is a front load, so it's not that big of a deal. But you'll be looking at every single cell to see if it matches one of 8 conditions to be added to the connection.
That
So
is a bit extreme.
exactly. So yes, this is a possibility. High processing, but once, while we could do a dual for loop out here, and hold on, maybe I may have just thought of a way to combine some of this. Yeah, these have to be separate. It's a cart before the horse problem. I still think we need the. I'm going to run with the dual for loop here.
Yep.
Because it kind of just, I don't see another way to do it right now. And I may figure it out later, but so we have cell dot connect 0. Oh, we got to pull the cell first. Yeah. Oh man. This is 3, 0, 3, 0. And 4, 0, 4, 0. Yes.
There's an
Why is it upset?
extra bracket in there.
Huh?
On the last one? Is it? No.
Is it not like the function?
Seems weird. There's a bracket in front of that comma. I don't know.
Oh, hold on. Watch this. Does that actually fix it up there? No. Okay. What the hell's going on? So we have that there, and then this.
Oh, is it looking for an extra argument?
Kind of looks like it. Oh, I see what I did wrong. Okay, hold on, maybe string. So this one should go to, that is correct. Then this, that's correct. You got nodes, node 1, node 2, and still in node 2, still in node 2, still in node 2. Wait.
So I try restarting GameMaker. It does this sometimes.
Yeah, I do. Yes. Love my clean desktop.
Pretty sweet.
Well, I stream. That's my primary thing. I don't want to have anything on there that might dox me. So I just keep everything off of it. Oops, I went into the wrong. Nope, didn't like it.
What the hell?
Okay, so what is, yeah. Well, I can't undo it. String format, string format. So that is going into there, it's going into there. That is that like that. And that is value, total, decimal, value, total, decimal. What the fuck is going on? Create world, add neighbor. Takes no more than 0. Create world. Oh,
Uh-huh.
I love that. Not really. It does not give you a very good. Whatever. It's like GameMaker is a great game making program, but it definitely needs some improvement in many places. But they're working on it and still in development, so I'm not going to give them too much shit. All right, that's correct. Love when I look back at stuff and be like, oh shit, that's not what it's supposed to be. Okay, so this connection node needs to equal. Okay, seriously, just stop hitting buttons, brewer. I'm just equals. Something I gotta do first. You know what enum is?
Nope.
So, this is my recommendation of how to do this. This way, you don't have to remember that array, because the way enums work is basically an abstraction out of values that are not going to change. So basically, east is always going to be east, northeast is always going to be northeast. So instead of having to remember, the directions to everything else, the way enums work is that it assigns a 0 to the first one, a 1 to this one, a 2 to the north, 3 to the northeast. Basically, in the order that you create these enums, it assigns a numerical value that you can then use to easily pull information or categorize or create a better understanding of what the data is and how it's being used. I use enums constantly in my game to kind of separate out all the different core aspects, such as I have 7 type of attacks in my game. I have an enum that lists out those attacks, so when I go to a switch statement, I can just figure out which one of the attacks is based on a value in these enums. I don't need to remember 0, 1, 2, 3, 4, and 5, 6, and 7 type of thing.
Is that going to
So let me
conflict
show you
with macros that I have that may have the same values?
No.
Okay.
Enums, it's basically like this is a struct, or this basically is a map that assigns this string to a incrementing value, incrementing number, with starting at 0, incrementing up in the order that you have it here. So as long as you keep this in the correct order, it'll always be 0, 1, 2, 3, 4. And now, because of that, you can do this. Instead of 0 here, we just have and it recognizes it as 0. So
Nice.
the benefit of this is now trying to think of the best way to actually pull the information. Cells. This would be cell dot cell explored. This string formats. And we're looking to the right. So this would be +1. Wait, no, this is wrong.
I was going to say, connect nodes. We don't want to look over one cell, do we?
Yeah, that's wrong. So we actually need to get I am looking at my notes here because it's this thing here that I'm working with now. So we need to pull this node first for the, or get the ID. We don't actually need to pull the node. We just need the ID. So creating a struct. Basically, I want to have one ID connecting to the next ID. So we need to cell, pulling in cell keys. I'm just thinking through something, or thinking this through. I don't necessarily need to have that, but connections. No, it's cell X and cell Y. Then okay, the X points. I have the cell, and so based upon this human lives, it is 0, 3, 1. Let's start there. Notes. One plus mm, 3, 0 plus this is Y. is 15. It's 31 by 31, right? Yeah. So it is this. Why is it not liking that? Why does it not? Fuck's sakes. I'm adding a struct to an array. This is not a problem. Why do you not like this? Did I use the wrong button? No. I'm pulling out a value that's a string. Oh. No. Oh, I see. I see. No, that's right. String format. Fucking Christ, what is wrong? Oh, I know what it is. Derp. Nah, that's my pin, kitty. Then hey, after I do this, I think we'll call it for now, but I think you'll have everything set up that you need. Here, this is really getting involved, ain't it? Have I thoroughly confused you yet?
I don't know what from and to is. Never seen that.
Sorry, I'll explain it. I'm just trying to get through my thoughts here. The same thing as note. It the what I have is for it's just a construct, not a construct, uh, struct. There it is. That and just from and to. It's just the values inside of the struct. I can't. My brain is thinking too many things at once here, and my cat's trying to play. I love you too, but just so string format, and we're looking to the right. So it is cell dot export plus 1, to 0 plus y. So we have the second cell. This is the cell to the right. 2 global dot nodes. I don't need this. But it is 0, 0, 0. So it would be 0, 2. And still 15 times 32, actually. These need to be 32 and 32. That's 31. Yeah, okay, that is correct. That is correct. It needs to be 32 because it's 32 long. It's just, okay. Times, I stuck at 31. So this is looking at 0 times 32 for the little to that node. 15 times 31. It's actually J. Okay, I think I have this. So connecting for the first cell to the east, we have the global nodes pulling in the node that is 31, assuming 0, then 15, because the next node below it would be plus 32, so it is times 32, so that's right. And we have going to the next node over.
Oh, I see. I see.
So this is actually 31 or 32 because we're adding it to 1 on the right hand side. So it is 32, and the next one will be the next 32 over. And now here is the same thing for this one, for going down. So then you need to do the same thing for all of these, just make the appropriate adjustments to the values here.
Yeah.
I will. Okay, so here we go. So for now, I think this is pretty. This sets you up pretty well, I think.
Yeah. Certainly a trickier one, but I loosely understand what's going on there.
Well, I mean, again, the offer stands for you just to hit me up if you ever need any help with this.
Cool.
Because it's not. This is not an easy thing to do, and what you are trying to do with the pathing is not an easy thing to do. But there is that. Save this. Save it a sec. All right, so there's that. You have that. Fuck. Yeah, so that turned into a. I thought it was going to be like a 20-minute phone call into how long now?
7 hours, maybe?
Really?
I don't know. I
Yeah.
guess.
Yeah, because it started at around 6.5 hours. 'Cause it
Uh,
started around
yeah, I've been
9
live
o'clock
for
my
nine
time.
hours, so
All right, so the people who were watching, that was an interesting exercise in math and
madness.
visualization, and yeah. But if you need me to come through and explain it again tomorrow, I can do that. Just yeah. But I think I am done for the day. I am not going to stream. And yeah. So all right. But questions before I take off for
No.
now?
Perfect timing. I think I'm pretty much done myself. But like you said, if you said you're probably going to take a look over it again tomorrow with fresh eyes, so I'll
Yeah.
probably be around. So if you want to involve me in that, I'd appreciate it.
Absolutely. I'll do. If I see something, I'll let you know. But for the most part, it should be good to go. But if I see a mistake in there, I'll definitely let you know. But
Okay.
I'll let you know when I'm done looking over it. I'll say it that way
Cool.
as well.
Well, thanks, man.
All right. So, woo, you're welcome. Yeah, have a good night, man. Yeah, get some rest.
Yeah, we'll do. Take it easy.
Later.
Bye. Holy smokes. Okay, that was fun. Yeah. I was enjoying the level of insanity that we were reaching there. This is going to be pretty sweet. Pretty sweet. The funny thing is I'm probably going to like stumble at the first hurdle with like the basics of how and where I should implement this stuff. Actually, a lot of the more complex stuff here, I'm pretty good with, but I can imagine myself getting stuck with something like super easy. But I'll do my best. I'll run with this tomorrow. I do kind of need to do some prep for the weekend tomorrow as well. So I might not stream 9 hours again tomorrow. I'll do what I can though, but yeah, I want to be ready for the weekend. I think really I'll probably be getting truly stuck into this stuff next week, depending on what the weather is doing as well, because I am supposed to be kind of taking some time off for the summer, but it's just been miserable this week, so I've not been going out. No, actually, the weather picks up from Saturday and looks pretty good going into next week. So hopefully with sufficient notes, etc., I can come back to this at a later date without just forgetting everything, because that would really not be great. But yeah, we're gonna do it. We're gonna really take a good crack at refactoring the pathfinding and then doing the search algorithm stuff as well, and see if we can salvage this project, which is now having some massive performance issues. Let's see if I can find somebody to raid. I am obviously done. I was trying to type in raid.tv. That's not a thing. Oh boy. What's Adeline doing? Ads are started. Can I snooze the ads maybe? Fuck, too late.
And actually could have probably had floating damage. Weird that this game doesn't have floating damage text. Entirely inappropriate in some games.
Playing Mega Man or something. I think I think we're gonna raid Hamster Hammer. Oh, he's got a green screen now. That seems to be a new addition. Okay. Oh, we're waiting on ads still. Freaking ads, dude. Alright, we back from ads? I gotta start maybe doing this thing where I like actually take a break on the ad breaks or something. That's a good idea. Why did I never think of that? Why do I have 7 emails? Good lord. I did get some mail today and I have neglected to run downstairs and pick it up. Yes, that was delivered. That's been delivered, but I haven't picked it up. I need a medical appointment coming up, and Stardeus is on my wish list, but I don't have any money, so I'm not gonna buy it. Oh my god, right. So I'm gonna take another look at this stuff tomorrow and really try and get it, like, cemented into my brain. Okay. But right now, I need to go to bed. So, I'm going to send you over to Hamster Hammer. Thanks for watching. I'll see you in the next one. Peace out.